Hey everyone, if you are new to the world of databases and want to dive into the exciting realm of NoSQL databases, then you are in the right place. This course is your key to unlocking the power of MongoDB, one of the most popular and versatile database systems in the world. In today's digital age, data is at the heart of everything we do. Whether you are building web applications, mobile apps, or handling massive amounts of data in your organization, a solid understanding of databases is essential. So, MongoDB is here to simplify your journey by offering a flexible, scalable, and user friendly database solution that is perfect for both beginners and experienced developers. This is the outline of the entire course. So I'm going to start by giving you a brief introduction of MongoDB. Then we are going to see some fundamentals about the MongoDB. After that, we will see how you can perform the CRUD operations. And we are going to see some query and projection operators as well. After that, we will see some update operators, and we are going to see how you can show the schemas and relationships in MongoDB. Then we will move one step further and see how you can use MongoDB Compass, and finally we are going to integrate MongoDB with different frameworks and languages. The course comprises of approximately 50 labs ranging from the beginner level concepts to intermediate and advanced levels. I'm going to start by setting up the environment on our Windows operating system to use the MongoDB as well as the MongoDB shell. Then we'll see how you can perform different type of CRUD operations in MongoDB along with using query, projection and update operators. And we are also going to see how you can depict different relationships between the documents in MongoDB. You are also going to see how you can use the MongoDB Compass and how you can integrate MongoDB with other frameworks. Welcome back. In this video, I am going to show you how you can install MongoDB on the Windows operating system. Follow the steps that will be shown in the video to install MongoDB Community Edition using the MongoDB installer wizard. The installation process installs both the MongoDB binaries as well as the default configuration file. So, the first step is to install the MongoDB community.msi installer from this particular link. From the version drop-down menu, select the version of MongoDB that you want to install for your system. From the platform drop-down, select Windows. And then finally from the package drop-down menu, select .msi and click download. It will take some time to download. After the download is completed, from the file explorer, go to the directory where MongoDB installer is downloaded and then double click the .msi file. The wizard steps you through the installation of MongoDB. To begin the setup, firstly agree to the license agreement. Then from the choose setup type, you can either choose complete or custom setup type. The complete setup will install MongoDB and the MongoDB tools to the specified location, whereas the custom setup allows you to specify which executables are installed. In service configuration, select Install MongoDB as a service. Then select either Run the service as network service user or Run the service as a local or domain user. Then select a service name and a suitable location for data directory and log directory. And click Next. Here you have the wizard to install MongoDB Compass along with MongoDB Community Edition. You can either check the checkbox to install or uncheck it. And then when you are ready, click Install. The installation will take some time to complete, and after completion of the installation, simply click Finish. And in this way, MongoDB will be downloaded to your system. And that's all for this video. In the next video, I'm gonna download the Mongo shell on the Windows operating system. Welcome back. In this video, I'm gonna show you how you can download and install MongoDB shell on the Windows operating system. The MongoDB shell is also called the Mongosh. So when you want to download the MongoDB shell, you have to go to the link mongodb.com/try/download/shell and you will be redirected to a page that looks like this. So here you have the option to download the MongoDB shell. If you scroll down a little bit, you will have all these options. I am going to leave the version as the default version because it is the latest version. Then if you clicked on the platform drop-down menu, you will have different operating systems and you can select the one that you want. Right now, I am going to install in my Windows operating system of 64-bit. So I am going to select the Windows 64-bit 8.1 plus MSI version, and you will see that the package will now be changed from the zip to the MSI. You can also download the zip file of the MongoDB shell as well, but then you will have to configure the path for the MongoDB shell. But if you install the MSI, it will be automatically configured for you. So once this is done, you simply have to click on download, and your file will start to download on your system. So you can see that our Mongo shell has been downloaded. So I'm gonna go to my downloads folder, and this is the installer or the .msi file for the Mongo. Double click on it, and the MongoDB shell setup wizard will appear. You simply have to select all of the options from here, like the location where you want to install it, and then keep clicking on next. Follow the prompts and simply click on install to install the Mongo shell. So I'm gonna come back once it is installed in my system. So now my MongoDB shell is downloaded and installed into my system. So if I go into the folder, you can see that these are all the files which are present inside it. And this is a bin directory inside which we have mongosh.exe, and if you click on it, this is the file that is going to open the Mongo shell for us. So if you see something like this written on the screen, so this means that you have successfully downloaded and installed and configured Mongo shell on your local system. So let's close it, and if you want to verify that you have successfully configured and installed MongoDB on your system, then from this directory, you simply have to open command prompt. So once your command prompt is opened, you have to type the command mongosh --help and press enter. So once you do that, if your Mongo shell is successfully configured and installed, you will see all these text about the Mongo shell help. But if there was any issue during the installation or configuration of the Mongo shell, then you will get an error. So right now we do not get any error. This means that we have successfully downloaded and installed MongoDB shell on our Windows operating system. So that's all for this video. I'll see you in the next one. Welcome back. In this video, you are going to learn about databases, collections, and documents in MongoDB. We'll be using documents and collections throughout this course, so it's important that you have a clear understanding of what the differences are. So, a document is defined as a record in a MongoDB collection and the basic unit of data in MongoDB. Documents can be thought of as equivalent to rows or records in a relational database, but with more flexibility. The MongoDB documents look like JSON objects, but they exist as BSON objects. Existing like a JSON object means it consists of key-value pairs, and the documents can have nested structures allowing for more complex and hierarchical data representation. Here's an example of a document that stores some data for an article. You can tell that it is stored using BSON because there is a quotation mark around both the key and value pairs. On the other hand, a collection is a group of MongoDB documents. Typically, all documents in a collection have a similar or related purpose. But basically, a collection is a grouping of MongoDB documents. The collections are the equivalent of tables in a relational database but do not require a fixed schema, allowing documents within the same collection to have different structures as well. Other point to remember is that collections are schemaless, meaning that documents within a collection can have different fields and data type. Collections are created automatically when you insert data into them. You do not need to create them explicitly before using them. So here is an example of a collection. In this example, we are storing two documents inside a collection and each document has some data about an article. Now let's see another example to understand the concept of database, collection and documents more clearly. Suppose you are building a database to store information about the books. In MongoDB, the database name will be library. Inside the library database, you can see that there is a collection named books. Each document in the books collection could represent an individual book with fields like title, author, publish date, and so on. These documents can have different fields based on the information available for each book. So in short, we can say that MongoDB uses databases to group related data, collections to group related documents, and documents to store the actual data, all in a flexible and schemaless format. This flexibility makes MongoDB suitable for various types of applications, especially those that require agility in handling evolving data structures. So that's all for this video. I'll see you in the next one. JSON, which stands for JavaScript Object Notation, and BSON, which stands for Binary JSON, are both data interchange formats used for representing structured data. While they share some similarities, they also have distinct differences that make them suitable for different use cases. Here is a comparison between JSON and BSON in terms of use cases, applications, when to use, performance, and other factors. Firstly, we are going to compare them on the basis of the use cases. So for JSON, it is primarily used for human-readable data interchange. It is commonly used for configuration files, web APIs, and data serialization in various programming languages. Moreover, JSON is well suited for data that does not require high performance or storage efficiency. BSON, on the other hand, is designed for efficient binary data serialization and storage. It is ideal for scenarios where data needs to be compactly represented and transmitted, such as in databases, network protocols, and high-performance applications. Moreover, BSON is particularly useful for applications where rapid encoding or decoding is crucial. Let's have a look at when to use which one. So you can use JSON when data interchange needs to be human readable and easy to edit. You can choose JSON for scenarios where interoperability with various programming languages and web technologies is crucial, and you can also use it for simple configuration files or non-performance critical applications. Whereas BSON can be used when compact binary representation and fast encoding or decoding are essential. You can choose BSON over JSON for high-performance applications, databases, and real-time systems. Moreover, when working with MongoDB or similar NoSQL databases that natively support BSON, then BSON is a better choice. Now, if we compare JSON and BSON in terms of performance, then JSON parsing and generation can be slower compared to BSON due to its textual representation. It may result in larger payload sizes, which can affect network efficiency and storage space. BSON, on the other hand, is designed for performance, offering efficient binary serialization and deserialization. It leads to smaller payload sizes, reducing data transfer times and storage requirements. If we summarize the whole discussion, then JSON is great for human-readable data interchange and interoperability across different systems and languages. BSON, on the other hand, is a binary format optimized for performance, storage efficiency, and specialized data types, making it well-suited for high-performance applications and databases like MongoDB. Your choice between JSON and BSON should depend on the specific requirements of your project. That's all for this video. I hope you now have a clear understanding of major differences between the two and when to use which one. Thank you. Welcome back. In this video, I'm going to show you how you can create databases and collections in MongoDB using the MongoDB shell. So the first thing that you need to do in order to create a database and collection in MongoDB is to open your Mongo shell. And it will look something like this. After opening your Mongo shell, you have to provide MongoDB connection string in order to establish a connection. So I'm going to pass the value here, which is MongoDB : localhost : and then you have to provide the port name for the MongoDB, which is 27017. And once this is done, hit enter and your connection will be successfully established. Now I'm going to clear my screen first. Okay, so this looks good now. After that, let's move towards creating the database. So I have already discussed with you that a database is basically used to group together multiple collections. This means that many collections can be present inside one database. So before creating a database, let's see if we have any database present or not, and for that we have to type the command show dbs and then place a semicolon. Once you hit enter, you will see a list of all the databases that are currently present to you in the MongoDB. If you are using MongoDB for the first time, then only these three databases will be available to you. These are all the databases that I have previously created. So you can use any of the database to perform different operations, but in this video we are going to focus on creating a new database. So I'm not going to use any of this. So in order to create a database, you do not need to use any specific command for creating a database. You can simply write the use keyword and then provide the database that you want to create. For example, if I want to create a database called university, then I'm going to simply say use university. So this command is going to do two things. Firstly, it will check whether this database is already present inside MongoDB or not. If this university database is already present, then it is simply going to use it for further processing. But if this university database is not present inside the list of databases, then firstly it is going to create this university database and then it is going to use it for further processing. So let's hit enter and you will see that now it is switched to DB University. So this means that university database was not present previously inside our list of databases, but now it has created this university database and it has switched to it. But let me show you one thing. If I use the command show DBS again, you will see that once again inside this database list you cannot see the newly created database. But I've previously said that once you run the command use university, it is going to create the university database. But it is not showing it here when we run the show databases. Why is that? This is because MongoDB has a simple rule that in order to have any database present inside the list of databases, then the database must have either a single collection or any type of data inside the database. So until and unless you have some collection present inside the database, only then it will be present inside the list of databases when you run the show DBS command. So I'm going to clear the screen. So you can see that our database has been created by simply using the use keyword and then providing the database name. Now the next step is to create a collection. In MongoDB, you cannot explicitly simply create a collection. You have to insert a record in a particular collection and then it will be automatically created. So let's say that I want to create a student collection inside my university database. So I am going to use the object DB. This DB refers to the currently used database, which is university. So I'm going to use DB dot. Then you have to provide the collection name which you want to create. So I want to create the collection student, and then you have to place another dot. And since I want to insert only a single record in it in order to create the collection, so I'm going to use the keyword insert one. Not a keyword, rather a function of MongoDB to insert data inside a collection. So once you have written it, now you have to go inside the brackets and you have to insert the data which needs to be inserted inside the student collection. And the data that you are going to insert using the insert one function is actually going to be the document inside the collection which is student. So I am going to insert the data which is this. So inside the insert one function, I am inserting the data. So you already know that in MongoDB we use the BSON format, which is the binary form of the JSON. So this is the data that we are going to insert. These are different notations that you can use. Firstly, I am passing the name and the value for the name key is John, and I am enclosed both of these values in double quotes. So this is one way of passing the key value pair. Then the next field is the age, which is an integer value. So you can see that you can also pass the values without the double quotation marks, and MongoDB will add the quotation marks on its own. Then this is the third field, which is a semester, and it is another notation that you can use, that for the semester I have not placed the double quotation marks, but when passing the integer value I have passed the double quotation marks. But all of this is correct. You can use any of the notation that you want. And the last field is a boolean value, which is graduated, and I have passed the false value to it. So this means that you can use any data type inside the insert one function while inserting data in order to create a collection. And these are all the notations that you can use for defining the key value pairs in the BSON format. So once this is done, now I'm gonna go ahead and hit enter. And once you do that, you can see that it has acknowledges to be true and the data has been inserted having the object ID this. Now let's verify that this operation has successfully created a collection named student inside our university database. So I am going to use the command show collections, and then I'm going to hit enter, and you will see that now it is showing me a single collection student that I created using the insert one function. So if I quickly summarize it, a database is a collection of multiple collections, and a collection has multiple documents inside it. In order to create a database, you can use the use keyword and then define the name of the database that you want to create. But until and unless a single collection is present inside the database, only then it will appear in the list of databases when you run the show DBS command. On the other hand, when you want to create a collection, you cannot explicitly create an empty collection. You need to insert a single document inside it to create a new collection by following this syntax. So this is how you can create databases and collections in MongoDB. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can create and insert a single document in a collection in MongoDB. So previously you have seen how you can create a database in MongoDB and then how you can create a collection inside a database. Now we are going to see how you can perform basic CRUD operations in MongoDB. So the CRUD operations include creating a document, retrieving a document, updating a document, and deleting a document. So in this video, we are going to see how you can create or insert a document inside a collection in MongoDB. So there are two ways of inserting a document. Either you can insert the document inside the collection one by one, and the other way is to insert many documents at once inside a collection. So right now we are going to focus on how you can add a single document inside a collection. So for that, firstly I am going to view all the databases which are present inside my MongoDB. So I'm going to write the command show DBS, and once I hit enter, you will see that these are all the databases which are currently available to me. So in the previous section, if you remember that I created this university database, so I'm going to use this database for this video as well. So I'm going to say use this university, and I am now switched to the DB university. Once I am inside the university, now I am going to see all the collections which are present inside it. So I'm gonna write the command show collections, and it is going to display me that right now there is only a single collection called student present inside it. So I'm going to insert data inside this collection, and for that I am going to use the DB object which refers to the university in which we are currently working. So you need to make sure that before using the DB object, you should be inside the database where the collection is present and inside which you want to insert the document. Okay, now after a dot, you have to provide the collection name, which is student, and then we have to provide the function insert one in order to insert a single document inside the collection. Then I'm going to go inside the brackets and I'm going to write this here. So I am going to insert these fields inside my document, which is name, and the value of name is Amy, age is 20, and is graduated is set to false. Now once I hit enter, you can see that the object have been successfully inserted inside my collection. So this is how you can insert a single document inside your collection. So let me add another one. So I'm going to use the same command and I'm going to change the values here. For the name, I'm going to say Anna, then the age is going to be 23. And here I am going to insert a new field for the semester, which is going to be 5. Okay, so you can see that the values that I passed for this document have an extra field which was not present for the first document. And this is because the collections inside which the documents are being placed are schemaless. This means that we do not have any specific key schema of what fields should be inserted inside the collection and what should be the data type of the fields. So you can have any number of fields inside the documents you want, and they must not be identical to all other documents present inside the collection. Okay, so once I hit enter, you will see that it will successfully insert the data inside the collection. Another thing to note is that if I add another student, let's say Jerry, I am going to leave the age to be same, and the thing that I want to show you is that for this document, I added the semester as an integer value, but it is not necessary to have the same data type for the field in the other document as well, which means that for the semester, instead of an integer value, I can pass a string value as well, and it is going to accept it without any errors. Okay, let's hit enter, and you can see that it has not given us an error, and it has successfully inserted the document inside the collection. Now, if I want to quickly view these inserted documents, I am going to use the command db.student.find, and this is going to display me all of the documents which are present inside the collection. Hit enter, and you will see that these are the documents which are present inside the collection. For the first document, you can see there is name, age, semester, and is graduated. Then for the second document, the semester is missing, only name, age, and is graduated are present. Then you can see that for the third document, we have semester as an integer value. And then for the other document, you can see we have the semester, but the value is not an integer, it is a string value. So this shows that there is no particular schema of a collection, and thus the documents can have any number of fields of any data type, and they must not be identical to each other. So this is how you can insert a single document or create a single document in MongoDB. In the next video, I am going to show you how you can insert multiple documents at once inside the collection. That's all for this video. I'll see you in the next one. Welcome back. In this video, I am going to show you how you can create and insert multiple documents at once in MongoDB. In the previous video, you have seen how you can insert a single document inside a collection. But before moving towards other CRUD operations, I am going to show you how you can insert multiple documents at once inside a collection, because there might be a scenario where you want to insert multiple records inside the collection. So in order to do so, firstly you have to open your MongoDB shell, and once you are inside the shell, establish a suitable connection by providing a connection string, and then you will be good to go. So the first thing is I'm gonna see what are the available databases. I'm doing this so that you'll get familiar with all these commands and you won't have to remember all of these. They will be on your fingertips. Okay, so these are the databases that I have. I'm going to use the university database. So I'm going to say use university. And once I do that, I'll be switched to the DB University. Then I'm gonna write the command show collections to view the collections that are currently available. And I have a single collection called student. So I'm gonna use it. So now we are going to go ahead and insert multiple documents at once inside the collection. So you remember that in order to insert documents inside the collection, you have to use db dot. Then you have to provide the collection name in which you want to insert the document, which is student. And then when we want to insert a single document inside the function, we use the function insert one. But now we want to insert multiple documents at once inside the collection. So I'm going to use the insert many function of the MongoDB. Then inside this function, since we are going to pass multiple objects, so you have to actually pass a list of documents inside the insert many function. And then all the documents that you want to insert inside the collection will be placed inside this list. So in simple words, you simply have to use the insert many function with the db.collection name, and this insert many function will contain a list of documents that will be inserted inside the collection. So now inside the list, you are going to add the documents one by one. So firstly, I'm gonna paste first document where the name is Sarah, age is 20 and semester is 4. Then I'm gonna place a comma here, and then you will have to add the second document and so on. So for the second document, I'm gonna add the following fields where the name is Mike, age is 22, semester is 4, and is graduated is false. Then similarly, you can add multiple documents here. I'm gonna add one more where the name is Andrew, semester is 7, department is CS, and is graduated is false. And you can see that even though we are adding these 3 documents at once inside the collection, but the fields inside each of these is different from the other one, which means that there is no particular schema that the documents are following, okay? So you can add any number of documents, and once you are ready to insert the documents, simply hit enter. Okay, CS should be in the double quotes. So you have to write double quotes here. Now hit enter, and you can see that 3 objects have been inserted, or 3 documents have been inserted inside the collection. Now if you quickly want to view the data which is inserted, then you can simply use db.student.find function, and it's going to display you all of the documents which are present inside the collection. So these are the documents that we have currently inserted. The first one is the Sarah having age and semester, then the Mike, and then Andrew. So you can see that using the insert many function of the MongoDB, we can insert or create multiple documents at once inside the collection. In the next video, I am going to show you how you can update the documents. But that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can update documents present inside the collection using a single filter. In the previous video of the section, you have seen that how you can create or insert a single document inside the MongoDB, and then you also saw how you can create and insert multiple documents at once inside the collection. Now we'll move one step further and we'll see how you can update any document present inside the collection. So the most important thing that needs to be done in order to update the document is to use a filter. So the filter will actually contain the condition that will be checked for each record and then the updated document. But before updating the data, I am going to insert a new dummy record inside my collection so that I can update it and show you how the filters work. So in order to insert a new document inside the collection, I am going to use this command, which is db.student.insert1. The name is Sam, age is 21, and semester is 4. Hit enter and you will see that the object or the document has been inserted. Now let me quickly see what are the documents which are present inside the collection. So I am going to say db.student.find, and you can see that these are all the documents which are present inside the collection currently. So I'm going to use this last document that I have just created in order to explain the updating function. For updating, you need to have a unique ID or some unique property on the basis of which you can find the document which you want to update. Here you can either use the object ID, but you don't remember the object ID of all the documents, so it is not admissible to use it. Then you can see that for all the students, the name field is different, so I'm going to use the name field here. So in order to update any document inside a collection, you simply have to use db, then you have to provide the name of the collection where the document is present, and then you have to use the update function. And then inside this function, you have to pass 2 values. The first one is going to be the searching criteria on the basis of which the documents will be searched, and the next one is going to be the updated record or the updated document. So let's say I want to update the record where the name is Sam. So I'm going to say name is Sam. This is going to be my searching criteria, and then for that I want to update the age. And since I want to update the age from 21 to 22, so for that you will use the set operators. For updating, I am going to go into the details of these operators later on in this course. But right now you need to remember that in order to set a value, you need to use the $set operator. place a colon, then curly braces, and then inside it, you have to define the field that you want to update. So I want to set the age to 22. Okay, so this is going to firstly find the document on the basis of the searching criteria, such as where the name is Sam. So it is going to look for this Sam here, and then it is going to set the age to 22. Place another bracket here. Now hit enter, and here is something interesting. So you can see that inserted ID is null, matched count is 0, modified count is 0, and upserted count is 0. I'm going to go into the details of upserted count in a minute, but let's just see that even though we have a record whose field name is Sam, but still it is showing the mesh count to be 0. Why is this? This is because the field names in MongoDB are case sensitive. So you can see that here the name field is starting from a small n, and when defining the searching criteria, I have placed capital N here. So it is considering this name to be different from this field. So whenever you pass the field name in the searching criteria, you need to make sure that it is in the same case as the field inside the document. So when we pass any field inside the update for the searching criteria, firstly it is going to find all of the documents where this name field is present, and then it is going to find the value that we have passed in all of the documents which have the name field. Okay, so you need to make sure that both of them are in the same case. Now let's run this command again, and I'm going to change the name from capital N to small n. Let's hit enter, and you can see that now we have the match count 1 and the modified count 0. So if I run the command db.student.find again, you can see that now the age of Sam is changed from 21 to 20. Okay, so this is how you can use a single filter to update a particular document inside the collection. Now let's see what is meant by upsert. So let's say if I use the command once again, and here I am going to say it Sammy, and I am going to set the age to 22. So you can see that right now we do not have any document where the name field has a value of Sammy. So if I run this command, if I hit enter, you can see that inserted ID is null, match count is 0, modified count is 0, and upserted count is 0. This is because we do not have any document where the name is Sammy. So here comes the upsert in action. So if I set upsert to true, then firstly, if I run this command, it is going to look for a document where the name field is Sammy. But if it does not find any such document inside the collection, then it is going to create a document inside the collection with the values that we have placed inside the updated document base. So if I run this command once again, I'm gonna add a third parameter here, inside which I am going to set upsert to true. So setting this upsert to true will ensure that MongoDB will firstly look for a document where the name field is Sammy, but if such field does not exist inside the collection, then it is going to create one for us. So now let's hit enter, and you can see that instead of inserted ID null, it has provided us an object ID. The match count is 0 because no such record exists. Modified count is 0 and upserted count is 1. So this means that MongoDB looked for this document inside the collection. It did not find any document matching this searching criteria, and we set the upsert to true, so it created a document for us and set the age to 22. Okay, that is why the upserted count is 1. If I run the command db.student.find once again, you can see that now I have a new document where the name is Sammy and the age is set to 22. So this is how upsert works, that it allows MongoDB to look for the object that matches the searching criteria, and if no such document exists inside the collection, then it is going to create such document inside the collection for us. So this is how you can update documents in MongoDB using a single filter and using upsert. In the next video, I'm gonna show you how you can use multiple filters to update a document in a collection. But that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can update a document using multiple filters in MongoDB. This video is actually an extension of the previous one. In the previous video, you saw how you can update a document inside a collection by using a single filter or by using a single searching criteria. But what if you have two or more documents that have the same value for the field that you placed in the searching criteria? Then what should we do? In such scenarios, you can place multiple fields as the searching criteria, which is also known as multiple filters. So let's go ahead and see how you can insert multiple filters to update a document. So for that, firstly, I am going to see all of the documents which are present inside the collections. I am going to use the command db.student.find, and you can see that these are all the documents which are currently present. So you can see that we already have a document having the name value for the SAM. So in order to explain when to use multiple filters, I am going to add a new document inside the collection where the name is going to be SAM and it is going to be the same name as another document. The age is going to be 19 and the semester is going to be 7. Okay, let's hit enter and the object will be inserted. Now if I run the db.student.find command again, now we have two objects where the name field is SAM, but the age and the semester value is different for both the objects or the documents. Okay, so what if I want to change the semester of this document having the name field SAM? How would I do that? If I simply add the filter that name equals to SAM, then MongoDB is going to fetch this document and this document because for both of these the name field is SAM. So in such a scenario, we need to add multiple filters to distinguish a document from other. So in this scenario, we are going to add another field in addition to the name as the selection criteria or the searching criteria. So now instead of using this command db.student.update and in the searching criteria, I simply write the name equal to SAM. I am going to add another field in order to distinguish the document. So I am going to use the second field to be age, and the age is going to be 22. So it is going to look for the document where the name field is SAM and the age is 22, which means this object. And what we want to do, we want to set the age to be, let's say, 23. Place another bracket here and this is fine. So now what MongoDB is going to do, it is going to see that we want to update a document inside the student collection where the name is SAM and age is 22, and it is going to fetch this document for us, and then it will see that we want to set the age to 23. So once I hit enter, you will see that match count is 1, modified count is 1 and upserted count is 0. This means that it has found this one document and it has modified it. Now if I run this db.student.find command once again, you can see that now we have one object named SAM where the age is 23 and the other one where the age is 19. This means that we have successfully fetched the correct document from our collection and updated its field. So this is how you can use multiple filters to update a document inside a collection. That's all for this video. I'll see you in the next one. Welcome back. In this video, I am going to show you how you can read all of the documents inside a collection and how you can read some specific documents on the basis of a criteria. In the previous videos of the section, you have seen how you can create single document and multiple documents inside a collection in MongoDB. Then you have also seen that how you can update a document by placing a single filter, and you have also seen how you can update any document by using multiple filters. And moreover, you have also seen how you can read all the documents inside a collection. So let me quickly run you through it. So if you want to view all of the data which is present inside the student collection, so I'm going to use the function db.student.find, and once I hit enter, it is going to return me all of the records or all of the documents which are currently present inside the student collection. But if we want to find document having a particular record or of a particular student, then in such scenarios you can also use filters inside the find function. So if you want to insert a filter inside a find function to find a particular result, you simply have to add curly braces here, and then you can define the criteria. For example, if I want to find all the documents where the name value is equal to Sam, let me make it capital S. So I'm going to pass the filter where name equals to Sam. Okay, so once I hit enter, you will see that it has returned me two documents where the name is Sam. One is of age 23 and the other one is of age 19. Now if you want to further specify that which Sam do you want, then you can add another filter in addition to the name. For example, we want to find this document where the age is 23. So inside the filter, you simply have to place a comma and then age the other filter, which is going to be age, and age is set to be 23. So now once you hit enter, you will see that it is going to return us a single document where the name is Sam and age is 23. Similarly, if you want to find all of the students whose age is 23, then you can simply use a single filter inside the find function where the age is 23, and then you simply have to hit enter, and it is going to return you all of the students or all of the documents where the age is 23. So this is how you can use the find function of MongoDB to find all the documents inside the collection, as well as to find specific documents on the basis of certain criteria or the filter. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm gonna show you how you can delete documents from a collection in MongoDB. Out of the 4 CRUD operations, up till now you have seen that we have performed 3 operations on the document, which is creating a document, updating a document, and reading a document. Now we are going to move towards the last operation, which is to delete a document. Deleting a document is very much similar to reading or finding the document from a collection, and in order to remove any document from a collection, you simply have to use the remove function with the collection name. So if you want to remove the document from a collection, you simply have to use db dot, then provide the collection name, and then use the remove function. But there is one difference between remove and find, which is if you write db.student.find and hit enter, it is going to return us all of the records that were present inside the collection. But if I write db.student.remove and hit enter, you will see that it will give me an error which says it is missing a required argument at the position 0. This means that we must provide any filter or anything inside this remove function in order for it to work. So now if you want to remove all of the documents present inside the collection, you have to provide certain parameter inside the function, and to remove all of the document, you simply have to leave the selection string to be empty. So if you do that and hit enter, then all the documents present inside the collection will be deleted. I'm gonna run this query at the end of this video to remove all of the documents. But right now I'm going to show you how you can remove any particular document from a collection. So let's say you want to delete a document where the name is Sam and the age of the student is 23. So you are going to pass the criteria here. Firstly, the name is Sam, and then you are going to pass that the age is 23. So once you do that and hit enter, it is going to find the record where the name is Sam and age is 23, and it is going to delete it. So you can see that deleted count is 1. Now if I run the command db.student.find and hit enter, you will see that we now only have one document where the name is Sam and the age is 19 because the other one has been removed. Let's clear the screen. Similarly, if you want to delete any record where the age is of a particular number, let's say where the age is 22. Okay, so I'm going to change the age to 22. So this query is going to find all of the documents where the age is 22 and is going to remove them. Once you hit enter, you will see that deleted count is 2. This means that we had 2 documents where the age was 22 and now they both are deleted. So now I think you have clearly understood how you can remove a particular document on the basis of any field from a collection. Let me show you one more example. If I want to remove any student on the basis of the ID of the student, then how can I do that? For that, firstly I am going to run the commands db.student.find, and let's say I want to delete this document here on the basis of this ID. So for that, I am going to use db.student.remove function, and for filter I am going to pass underscore ID here, and for the value of the ID you will have to copy all of this value including the object ID to paste inside the value for ID. If you only copy these numeric values, then it is going to give you an error. So that is why you have to select the whole object ID and don't forget to enclose them in single quotes. So I'm going to do the same, and then let's hit enter. The deleted count is 0. Maybe I have to remove the double quotes from here. Now let's hit enter. For some reason it is not deleting the ID. I was enclosing all of this in single quote. Instead I have to enclose this in single quote. Let me remove single quote from here as well and place it here. Now let's hit enter and you will see that the deleted count is 1. So this means that we have successfully deleted this object having the object ID of this value where the name is Sam and age is 19. Let's confirm it by using the db.student.find function. Once you hit enter, you will see that now you do not have the document where the name is Sam and age is 19. Okay, so this is how you can delete any particular document from the collection. But if you want to remove all of the documents at once from a collection, then you can simply pass empty braces here in order to delete all of the objects. So if you want to remove all the documents, you will use db.student.remove and keep the braces empty and simply hit enter, and you will see that 7 documents have been deleted. Now if you run the command db.student.find, it is not going to return anything because nothing is present inside our student collection and all of our documents have been deleted. So this is how you can delete documents from a collection one by one or all at once. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm gonna show you how you can import a JSON file to MongoDB using the MongoDB shell. Before we move towards data import, there are some steps that must be performed in order to use the Mongo import utility. And for that, from the start window, search cmd and run it as administrator. Once command prompt is opened, we will change the current directory to the directory where your MongoDB folder is present. After changing the directory, now we will run the Mongo import command to import the JSON file. For that, type the command as shown on the screen. Here, we will use the JSON array flag to define that our file is going to be a JSON file. Then we will use the DB flag to give the name of the database into which you want to import the data. The database name can be of an existing database, or if the collection of such name does not exist, then a new database of the same name will be created. Similarly, we will use the collection flag to mention the name of the collection, and here you can see that my JSON file is placed in the same directory, so I will simply give the name of the file instead of providing its complete path. Then press enter and you will see that your file will be imported to the database successfully. Now we will move towards the second step, which is to check the imported data and to check whether the data has been successfully imported into the database or not. And for that, we will open our Mongo shell and we will make a connection to our MongoDB server running on the local machine. Once the connection is established, we will then run the show DBS command to view that our database into which we migrated the data is successfully created. We will use this database CardDB to check whether the data has been successfully imported or not. Then we will enter the command db.cars.find to display all the records present in the collection. Upon executing the command, you will see that all the data from the JSON file has been successfully migrated to our cars DB. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can import a CSV file to MongoDB using the MongoDB shell. Before we move towards data import, there are some steps that must be performed in order to use the Mongo import utility. And for that, from the start window, search cmd and run it as administrator. Once command prompt is opened, we will change the current directory to the directory where your MongoDB folder is present. Now we are going to import the CSV file into our MongoDB database, and for that, once again, we are going to use the Mongo import command. Here, first we will define the type of the file that we are going to import, which is a CSV file. Then we will use the DB flag to define the name of the database into which we want to import the data. Then we will use the collection flag to explain the name of the collection into which we want to import the data. Then we will use the file flag to give the path of the file where it is present. Here my file is present in the D directory, so I am going to provide its path with the extension. And finally, we are going to use the header line flag, which is going to tell the Mongo import utility to start reading the file from the first line. Upon executing the query, you can see that our CSV file has been successfully imported into our database. Now we are going to see whether the data has been actually imported or not using the Mongo shell. Now in the Mongo shell, first we will use the show DBS command to view all the databases. Here you can see that our database petDB has been created. Now let's check whether the data has been imported or not. Here we are going to use the database, and after using the database, we are going to display all the collections which are present in the petDB. Here you can see that pets collection is present. Now we are going to use the function db.pets.find, and it is going to display all the records that are present in the pets collection. Here you can see that all the data which was present in our CSV file has been successfully migrated to the petsDB database into the collection pets. And this is how you can import different types of data into the MongoDB using the Mongo shell. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of EQ operator and how you can use the EQ operator in MongoDB. Let's start the video by seeing what is an EQ operator. So the EQ operator matches documents where the value of a field equals the specified field. It actually specifies an equality condition. In simple words, you can say that if you want to find any particular field inside a document, then you can use the EQ operator. Since during this entire section, I am going to focus on different operators. So let's just go ahead and create a new database for this section. So let's go ahead and create. I'm going to create a database called store, and for that I am going to write the query use store, and once I hit enter, you will see that my database is switched to DB stored, which means that our store database have been created. But if you remember that until we create any collection inside the store, only then it will be displayed in the list of the databases. So let me create a collection inside the store. So I'm going to go ahead and create a collection. For that, I am going to use the function db.createCollection, and I'm going to create a collection named inventory. So I'm going to pass inventory inside the create collection function, and once you hit enter, you will see that it has acknowledged that a collection has been created. Now if you say show collection and you hit enter, then it is going to show you that inventory collection has been created. Now I am going to insert some document inside the collection on which I am going to display the working of different operators. So I am going to use the commands. Here I am using the db.inventory.insert many function to insert multiple rows at once inside the collection. So you can see that for the document, the first attribute is ID, second field is the item, and this item further has two fields called name and code. Then we have a third field for quantity, and the fourth field is tags, which actually contains a list of elements for the first one, second one, third one, and fourth one. But for the fifth document, you can see the tags has a list, and then this list has a nested list as its field. Okay, so I am using all of this to see how you can use the operators to get the record from different scenarios. Okay, let's hit enter and you will see that 5 rows have been inserted. Now, if I run the command db.inventory.find and I hit enter, then it is going to return me all of the documents that are present inside the collection. Now, if I want to get all of the documents where the quantity is 20, so for that I can use the equal operator. And how can I use it? You will simply use db.inventory.find function, and inside the find function, you know that you have to provide a filter in order to find any particular value. And since we want to find all the records where the quantity is 20, so the first field is going to be quantity, place a semicolon, and then it is again going to have an object inside it. And inside this object, you will use the EQ operator, place a colon, and then define 20. So it is going to firstly look into the inventory and call the find function where the quantity, okay, the spelling of quantity, where the quantity is equal to 20. So once I hit enter, it is going to return me all the documents where the quantity field is equal to 20. So right now, it has returned me 2 documents where the quantity is 20. I hope this is clear to you. Let me clear the screen from now. And if you look at the data set, this is the data that I inserted inside my collection and you don't need to write it. This file will be present in the GitHub repository with the name eqoperator.txt. Okay, so you can see that this is the data that we inserted inside our collection. And firstly, we searched for all the documents where the quantity was 20. Now, we want to find the documents where the name is equal to AB. How can you do that? Since you can see that inside the first document, we have a field item, and then this item has an other object where the name field is present. So, this name belongs to item. Just like we can say that in classes, we say a field belongs to a class. So how can we access it? We can access it using a dot operator. So this is exactly how we are going to access the name in MongoDB. So let's go ahead to our Mongo shell. And here I am going to once again run the command db.inventory.find. And inside this function, since we want to find the documents where the name field of the item field is equal to AB. So you have to firstly add curly braces here, which is going to represent our filter, and then you have to place double quotes, and inside the double quotes you will firstly have to write item because the name field is present inside the item, then place a dot and then name. So this function is going to look for item dot name field inside a document, and then you're gonna have to place a semicolon, then another object value inside which you are going to use the EQ operator and then define that it is going to be AB. Let's change it to double quotes. Okay, where the name is equal to AB. So this function is firstly going to look inside the item field of all the documents, and then inside the item field it is going to look for a name field, and then it is going to fetch the document where the name is equal to AB. So once I hit enter, you will see that it has fetched a single record where the item field has a name field whose value is AB. Okay, so this is how you can get values where a field has a nested field inside it. Let's go back to the dataset. This is a dataset. So now if we come to the tags, you can see that for the tag value, we have a list for all the documents. So what if we want to find a particular element inside the list? Let's say we want to find the element B. Then how can we do that? Let's go back to our shell. And once again, I am going to use the command db.inventory.find, place the filter brackets here, and I have to look for the B value inside the tags. And for that, I am going to define tags colon. Then you have to use another object where you will pass the EQ operator and you will simply enclose the B in double quotes. That's it. It's as simple as this, that you simply have to go inside the tags and it is going to look for all the documents that have an attribute or a field B. Hit enter and see that which of the documents you get. Firstly, you get a document for the ID 1, ID 2, ID 3 and ID 4. So here you can see that you got this document, you got this one and this one, because all four of them have the attribute B inside the list. But you must be thinking that why this document was not fetched in the result set although it has an attribute B. This is because if you clearly see inside this that this tag has a list and then this A and B attribute are present inside a nested list. So this whole field is actually a separate field present inside the tags field. So this B cannot exist independently. It is present inside the list. So that is why when we look for B field inside the tag, all the B values which were present inside a single list were listed down. But since this B was present inside a nested list, that is why this document was not fetched. Now, what if we want to get this B value or this entire object? How you can fetch it? Go to our MongoDB shell. I am going to clear the screen once again. And I am going to use the command db.inventory.find. And right now we have to look for the object or the document where the tags has a field of A and B. Okay, so for that I am going to use the EQ operator and then you simply have to insert the square braces and inside it you will define A inside the double quotes and then B inside the double quotes. And that's it. So what this is going to do, it is going to go inside the inventory collection and find all the documents where the tags field has an attribute or a field equal to a list containing A and B. So once you hit enter, what do you think will be returned? You must be thinking that it is going to return this A and B list since it is enclosed inside a list. But in reality, it is going to return us this document too. This is because here also the tags field contains a list that has an A attribute and B attribute. Let's hit enter to verify it. And yes, you can see that firstly it has returned us a document having the ID 3 and then the document with the ID 5, and both of them have the attribute AB. So you can see from the dataset that once we define that we have to find the documents where the tags value contains a list having attribute A and B, it fetched this document because it also has a list containing A and B, and also this document where there was a nested list inside the list having attributes A and B. But you must be thinking that why this document was not fetched although it also contains a list and the attributes A and B. This is because I have already mentioned that MongoDB is case sensitive as well as order sensitive. This means that tags AB is not equal to text BA. The order must be the same. So this is why only the document of ID 3 and ID 5 were fetched and 4 was not fetched because the order of the elements was different inside the text field. So this is how you can use the EQ operator to find the documents that matches a specified condition or a specified field. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I am going to show you what is the purpose of GT operator and how you can use the GT operator in MongoDB. The GT operator in MongoDB is a comparison operator. It matches if values are greater than the given value, and if they are greater, then it returns a document containing the value. The GT operator is also called the greater than operator. In this video, I am going to use the same dataset that I used for the previous videos, and it is going to be used in all of the videos of this section. So let me quickly see what is present inside my inventory collection. So I am going to use the command db.inventory.find, and once I hit enter, you will see all the documents which are currently present inside our collection. Now let's say that if we want to find all of the documents where the quantity is greater than 20, so how can we do that? This can be done by using the command db.inventory.find, and inside this function you have to provide a filter, and then inside this filter says we want to find the documents on the basis of quantity. So the first field is going to be quantity, place a colon just like we did for the EQ operator, then define an object, and then in place of EQ operator, since we are now working with the GT operator or the greater than operator, we are going to use the greater than operator, place a colon and add 20. So now the MongoDB is going to go inside our inventory collection and find all the documents where the quantity is greater than 20. Okay, let's hit enter, and you will see that it has returned me 2 documents having ID 3 and ID 4 where the quantity of the object is 25 and 30, and both of these are greater than 20. So this is how the GT operator works. Here is also an extension of the GT operator, which is GTE operator, or the greater than or equal to operator. So this operator is going to not only fetch the values which are greater than a specified value, but also the value which is equal to the value of the field specified. So let's say if I extend this example and I want to find all of the documents inside the inventory collection where the quantity is greater than or equal to 20, then I simply have to use the GTE operator in place of GTE, and all the other command will be as it is. So now the MongoDB is going to look inside the inventory collection to find all the documents where the quantity is greater than or equal to 20. So now in place of 2 documents, I am going to get 4 documents. First one is of ID 2 where the quantity is 20, then ID 3 quantity 25 which is greater than 20, then ID 4 having the quantity 30 which is greater than 20, and then ID 5 where the quantity is 20. So the GT operator is used to fetch all the documents where the value of the field is greater than the specified field, and the GTE operator is used to fetch all the documents where the value of a field is greater than or equal to the specified value. So this is how you can use the GT operator to find the values greater than the specified value. That's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of LT operator and how you can use the LT operator in MongoDB. In the previous video, you saw how you can use the GT or the greater than operator in MongoDB, and the analogy and the working of the GT operator and the LT operator is the same, but the difference is that the GT operator is used to find all the documents where the value of a field is greater than the specified value, whereas in the less than operator, it is used to fetch all the documents where the value of a field is less than the specified value. So let's quickly have a look at the data present inside a collection, and for that we are going to use the command db.inventory.find, and you can see that this is the data which is currently present inside a collection inventory. So if I want to find all the documents where the value of quantity is less than 20, so I can simply use the less than operator inside the find function. How can you do that? Simply have to say db.inventory.find. Inside the find function, you have to define a filter. And since we want to check the value of the field quantity, so we are going to say quantity colon, then place an object here. The first attribute is going to be the operator which is less than, in this case, place a colon and then place 20. So now it is going to go inside the inventory collection and find all the documents where the value of the field quantity is less than 20. So once you hit enter, you will get a single document having the ID 1 where the quantity is 50, which is less than 20. Then comes an extension of the less than operator, which is the LTE operator, or the less than or equal to operator. This operator is used to get all the documents where the value of a field is less than or equal to the specified value. So if I say that I want to fetch all the documents where the value of quantity is less than or equal to 20, then the above command can be changed by using the LTE operator instead of LT operator. So once I hit enter, now instead of a single document, I am getting 3 documents having ID 1, ID 2 and ID 5, where the value of quantity is 15, 20 and 20 respectively. So now instead of getting only the document where the quantity was less than 20, it is also fetched the document where the quantity is either equal to 20 or less than 20. So that is why we got 3 documents in the result. So this is how you can use the LT or the less than operator to find all the documents having the value of a field less than the specified value. That's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of the in operator and how you can use the in operator in MongoDB. The in operator is very simple but very important operator in MongoDB. The in operator selects the documents where the value of a field equals any value in the specified array. This means that instead of finding documents on the basis of a single field, you can find documents by specifying multiple fields using the in operator. When we use the EQ operator, you can define a single field value with the EQ operator to find the document having the specific value. But when you use the in operator, you can actually provide a list of values for a specified field, and all the documents that have any of the value present inside the list specifying the in operator will be fetched in the result set. So let's quickly see the data which is present inside our collection. So I'm going to use the command db.inventory.find function and hit enter. So you can see that this is the data which is currently present inside our collection. So now if I want to look for all the documents where the quantity is either 15, 20 or 25, then instead of writing 3 different queries to get the documents having the quantity 15, 20 or 25, I am going to use the in operator to get the documents having the quantity 15, 20 or 25 using a single query instead of writing the multiple queries. So how can I do that? Simply you have to write the function db.inventory.find, then you have to define a filter. Inside the filter, we want to fetch the documents on the basis of the field quantity. So I'm going to define the quantity, place a colon, then you have to add an object. The first value is going to be the filter, and here we are going to use the in filter. Instead of the EQ operator, place a colon, and then you have to provide a list of values. So I'm going to create a list, and inside the list I'm going to define the values 15, 20 and 25. So now MongoDB is going to go inside our inventory collection and find all of the documents where the quantity field has a value that is in the list 15, 20 and 25. So now once you hit enter, you will see that it will fetch 4 documents for us having the quantity 15, then quantity 20, 25 and 20. So in this way you can see that we have fetched the documents having the quantity 15, 20 and 25 by writing a single command instead of writing 3 different commands using the EQ operator. So this is the advantage of the in operator, that you can specify a list of values to match the values of the field present inside the documents and then fetch the documents. So this is how you can use the in operator. That's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of the not equal operator and how you can use the not equal operator in MongoDB. The any operator is also called the not equal operator. The not equal operator selects the documents where the value of a specified field is not equal to the specified value. This includes documents that do not contain the specified field. Its functionality is opposite to the equal operator, where the documents are fetched which contains the value equal to the specified value, but in the not equal to scenario, all those documents will be fetched where the value of the field is not equal to the specified field. So let's see this with an example. Firstly, let's quickly see what is the data present inside a collection, and for that I am going to use the command db.inventory.find. And once you hit enter, you will see that this is the data which is currently present inside our inventory collection. Let's clear the screen. So this is the dataset that we have in our collection right now. So out of this dataset, if I want to fetch all of the documents where the quantity is not equal to 20, which means that I want to fetch the document having quantity 15, quantity 25 and quantity 30 at once, then I will use the not equal to operator, in which I am going to specify that quantity is not equal to 20. Let's go to our MongoDB shell. And from here, firstly, you are going to use the command db.inventory.find, and inside the find function, you are going to firstly add the field that you want to specify, which in this case is the quantity, place a colon, and then inside these braces, we are going to specify our operator, which in this scenario is not equal to, and the quantity is not equal to 20. So this query is firstly going to look inside the database and then go inside the inventory collection and find all the documents where the quantity is not equal to 20. Once you hit enter, you will get 3 documents in the result having quantity 15, quantity 25 and quantity 30. So this means that our query has fetched all the documents where the quantity field was not equal to 20. Let's see another example. If I want to find all of the records where name field is not equal to AB, so we can do so by using item.name and then place a colon, and then you are going to define the not equal to operator and then in the double quotes define AB. So this query is going to result all of the documents where the item.name field is not equal to AB. Let's hit enter, and you can see that it has fetched me all of the documents where the item.name field is not equal to AB. So this is how you can use the not equal operator to fetch all of the documents having a field value not equal to the specified value. That's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of the not an operator and how you can use the not an operator in MongoDB. So the in operator is also called the not an operator. It is also a type of comparison operator in MongoDB. This operator is used to select those documents where the value of the field is not equal to any of the given value in the array and the field that does not exist. So we can say that it is very much similar to the not equal to operator, but with the not equal to operator, you can specify a single field to match with the fields of the document. But in case of the not an operator, you can specify a list of values inside the filter that would be matched with the fields of the document. Okay, so this is the data that we are currently working in and is present inside a collection. So if I want to fetch all of the record or all of the documents from the collection where the quantity is not 15 and not 20, which means that I want to fetch the documents having the quantity 25 and 30. So how can I do that? I can simply use the not in operator, and inside it I can define the values to be 15 and 20. So all of the documents that do not contain the quantity 15 and 20 will be selected in order to be displayed in the result set. Let's see it practically. Go to your MongoDB shell, and the first command that I'm going to use is the db.inventory.find, and inside this I'm going to define the filter. So the filter field is going to be quantity. Then I'm going to define the parameters, which is going to be firstly the operator, which in this case is not in, and you know that in case of in and not an operator, you have to specify a list of values. So I'm going to specify 15 and 20 here. So this query is going to select all of the documents from the inventory collection where the quantity is not inside this list of values, and this list of values contain 15 and 20. So all the documents having the quantity other than 15 and 20 will be selected. Hit enter and you will see that you get two documents in the result set having quantity 25 and having quantity 30. So this is how you can use the not an operator to get the documents having the values not equal to a value specified in a list with the not equal to operator. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of the OR operator and how you can use the OR operator in MongoDB. The OR operator in MongoDB works in the same way just like any other programming language. So, the OR operator is used to perform logical OR operation on the array of two or more expressions and selects or retrieve only those documents that match at least one of the given expressions in an array. In simple words, we can say that with the OR operator, we specify more than one condition expression, or we can also say a list of condition expressions, and all those documents will be fetched in the result set that specify at least one of the conditions specified with the OR operation. So let's see this with an example. Firstly, I am going to look for the data which is present inside the inventory. So I'm going to use the command db.inventory.find. And once I hit enter, you can see that this is the data which is currently present inside my collection. So out of this data, if I want to get all of the records where the name field is AB or quantity is 20. Okay, so all those documents will be fetched where either the name field of the item is AB or the quantity is 20. So how can you run the command? You can simply write db.inventory.find inside the find function. Firstly, you have to define the operator here, which in this case is OR operator, and then with the OR operator you have to specify a list of condition expressions. So we are going to create a list, and then inside this list we will specify the conditions one by one like so. So inside the first condition we are going to specify that item.name is equal to AB. So we are going to write item.name inside the double quotes, and then we are going to define that its value is equal to 20. So here we are going to use the equal operator and define AB inside the double quotes. So you can see that this is our first condition expression for the OR operator where the item.name is equal to AB. Then we are going to move towards our second expression where we have to define that quantity is equal to 15. So you can simply define it as quantity, place a colon, and then inside the filter you need to use the operator which is equal to, and then define 20. So this is the syntax of the OR operator, that you define a list of condition expressions inside it. And here with the OR operator, firstly we have used the condition item.name is equal to AB, and the second condition is quantity is equal to 20. So now MongoDB is going to fetch all of the documents which specify either of the two conditions, which means that even if only one condition is satisfied by a document, then it will be fetched in the result set. So once I hit enter, you will see that I am getting 3 documents in the result set, where the first one have the name AB but the quantity is not equal to 20. For the second document, you can see that name value is not equal to AB but the quantity is 20, and same is the case for the third document. So this means that it has fetched all of the documents that were satisfying one of the conditions specified with the OR operator. And similarly, you can use any number of condition expressions inside the OR operator, and if any single one of those expression is satisfied, then the document will be fetched in the result set. So this is how you can use the OR operator in MongoDB to specify a list of conditions in order to fetch the document. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of AND operator and how you can use the AND operator in MongoDB. The AND operator in MongoDB works in the same way just like it does in any of the programming language. The AND operator is a logical operator and it performs a logical AND operation on an array of 2 or more expressions and selects the documents that specify all the expressions in the array. This means that with the AND operation, you have to specify a list of condition expressions in order to test it, and all the documents that satisfy all of the conditions that are present with the AND operation will be selected for the result. So this is the dataset which is currently present inside my inventory collection. Out of this dataset, if I want to get all of the documents where the quantity is not equal to 20 and the tags contain B. So if I run this command, then for the first value, we'll see that quantity is not equal to 20 is being satisfied and the tags contain B. So this document will be fetched in the result. Then for the second document, you will see that quantity is not equal to 20 is not satisfied because the quantity is 20. So it is not going to check the second condition and will move towards the next document. For the next document, the quantity is 25 and the tags contain B. So it will also be in the result set. Same goes for the fourth one. But for the last one, since the quantity is 20, so this will not be fetched in the result. So once I run the query, it is going to give me ID1, ID3 and ID4 in the result set. Now let's quickly go to your MongoDB shell, and here I am going to run the command. For that, firstly I am going to write db.inventory.find, and inside this function, you know that logical operator comes first and then the conditions come. So inside this braces, you have to define the logical operator, which in this scenario is AND operator, and then you have to specify multiple conditions. So you are going to define the condition expressions inside the list, and the expressions will be present inside the list like so, but there have to be a comma between them. Okay, so now let's quickly specify the conditions one by one. So the first condition is that quantity is not equal to 20. So I'm going to define the field here, place a colon, and then use the comparison operator to check all the documents where the quantity is not equal to 20. So this is our first condition where the quantity is not equal to 20. And for the second conditions, we have to see that tags contain B. So you are going to define tags, and then you have to place the filter for the tags, and here we want to find all of the documents which contain B. So we are going to say equals and then place B inside double quotes since it is a string. So now the MongoDB is going to go inside the inventory collection and find all the documents that satisfy both of the conditions. And once you hit enter, you will see that you get 3 documents in the result set, and all 3 of them satisfy both the conditions that we mentioned with the AND operator. And similarly, you can add any number of condition expressions you want. So if I quickly go ahead and change this command a bit and add a third condition. So I am going to place a comma here, and I am going to specify a third condition, which is going to be that item dot name is equal to AB. So we are going to define the operator here, which is equal to, and then inside the double quotes you have to define AB. So here you can see that I've added a third condition. So all the documents must satisfy the all three conditions in order to appear in the result set. So in the previous query, it was fetching 3 documents for us, but now once I added another condition and hit enter, you will see that now it is giving me only one document, because only this document satisfies all of the 3 conditions present inside the AND operator, which is that quantity is not equal to 20, the tags contain the element B, and the name equals AP. So this is how you can use the AND operator. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the NOT operator and how you can use the NOT operator in MongoDB. The NOT operator in MongoDB performs a logical NOT on the operation expression and then selects the documents that do not match the expression. You need to remember that the NOT operation does not have any purpose of its own. It simply affects and alters other operators, and it cannot check fields and documents independently. And there are scenarios where you might say that the purpose of using the NOT operator is not justified because the task can be done using the not equal to operator. And this is somewhat true. But as discussed earlier, that the NOT operator does not have any function of its own. It simply affects and alters the function of other operators. So you can use the NOT operator simply for logical disjunction and use the not equal to operator to test the contents of the field directly. And there might come different scenarios where you would say that this function can be performed using different operator other than the NOT operator, and it is true. But in some scenarios, you will be required to use the NOT operator. Now let's quickly see how you can use the NOT operator. But before that, let me see what is the data present inside my collection. So I'm going to run the command db.inventory.find, hit enter, and you will see that this is the data which is currently present inside our collection. Now, out of this data, if you want to find all the documents where the quantity is not 20, so you are going to define it as, firstly you will define the attribute, which is quantity in this case, and then you will define the condition on the basis of which document will be selected. So firstly I am going to say equal to 20. So if I simply run this, it is going to select all the documents where the quantity is equal to 20. But I want to have all the documents where the quantity is not equal to 20. So I'm gonna come here and I'm simply going to add the NOT operator in front of this comparison equation in order to negate the result of this expression. So now MongoDB will firstly check this condition that quantity is equal to 20, but then since there is a not present, the whole equation will be converted to true if it is false and will be converted to false if it is true, and the document will be selected. So this in turn is going to select all the documents where the quantity is not equal to 20. Hit enter and you can see that it has fetched 3 documents having quantities which are not equal to 20. And similarly, you can use this with other operators as well, like in place of equal to, you can use the greater than operator. And now this command is going to fetch all the documents where the quantity is not greater than 20. So if I run this command, it is going to give me quantity 15 and quantity 20, and 25 and 30 will not be fetched in the result set. Let's go ahead and hit enter, and you can see that it has fetched me documents where the quantity is 15 and 20, and all the documents where the quantity was greater than 20 was not selected. So this is how you can use the not operator to negate the values of any other operator. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm gonna show you what is the purpose of exist operator and how you can use the exist operator in MongoDB. The MongoDB exist operator does not correspond to the SQL operator. The exist operator in SQL is used to find whether a particular record or field exists in a list of or array of records, which in case of MongoDB is performed by the in operator. So the exist operator in MongoDB matches the documents that contain or do not contain a specified field, including the documents where the field value is null. In simple words, we can say that the exist operator is used to find whether a particular field is present in a document or not. This can be useful for the scenario where you have record of multiple students and you want to find the aggregate score of all the students in a particular course. And simply by looking at the data, you will not understand that whether a student has taken any course or not. So in such scenarios, you can use the exist operator to find that course. So all the students that would have a field for that particular course will be fetched in the result set, and then the aggregate marks of all those students will be calculated for the particular course. So in such scenarios, the exist operator in MongoDB is useful. So this is the data set which I am currently working on. These are the rows that have already been ingested inside the collection. And now, in order to show you what the working of exist operator, I am going to add these two new documents inside the collection. And if you notice that these two documents does not have the quantity field inside them. Let's go ahead, copy this, go to your MongoDB shell and place it here. Hit enter and you can see that two rows have been inserted having ID 6 and ID 7. Now if you go ahead and run the command db.inventory.find, you will see that now instead of 5 documents, you are getting 6 documents, and these are the two that I have just inserted. So now I am going to show you how you can use the exist operator in MongoDB. As already mentioned that MongoDB is used to find the presence of a particular field inside a document. So if I want to fetch all of the documents where the quantity field exists, for that I can use the exist operator. And how can you use it? You simply have to use the command db.inventory.find, and inside this, since you want to find the quantity, so firstly I am going to place quantity here, and then inside these brackets you can use the exists operator and then set it to true. You need to remember that the exist operator takes only two values, true or false. True means that the quantity exists in the document, and false means that the quantity does not exist in the document. So here in this scenario, MongoDB is going to go inside the inventory collection and find all the documents where the quantity field exists, because we have set the exists operator to true. So now it is going to fetch all the documents where the quantity field exists. Hit enter and you can see that it has fetched 5 documents where the quantity field is present. Now if you want to see all the documents which do not have quantity field, then you can simply set this exist operator to false, and now it is going to fetch all the documents where the quantity field does not exist. Now let's move one step further. What if you want to add an additional check to the documents in addition to existence of a particular field? Then how you can do that? Let's say we want to find all of the documents where the quantity exists and it is equal to 20. Okay, so firstly we are going to test whether the quantity field exists, and if it exists, then if it is equal to 20, then all the documents will be fetched. So the above statement can be changed as exist will be set to true, and then here you will simply place a comma and then pass the other condition, which is quantity equal to 20. So now we have defined two conditions here. Firstly, if the quantity field exists and the quantity is equal to 20. This can also be done using the AND operator, but even without AND operator, it will work fine and you can define any number of conditions that you want. Now when you hit enter, you will see that it has returned you two documents where the quantity field exists and it is equal to 20. You can also use exist operator to place a condition on one field and also check the value of another field. Let's say we want to find all of the documents where the quantity field exists and the tags contain B. So you can see that here we are using two fields instead of one. In this scenario, we were placing the two conditions on the quantity field, but now we want to check if the quantity exists. So the exist operator will be used with the quantity field, and then we want to see whether the tags value is B. So the tags is a different field and we are going to use a separate operator with it. So how can you do that? You simply have to write the command db.inventory.find, and inside this, firstly, you are going to define that quantity exists, and here you will simply pass exist operator and set it to true. So this is our first condition. Since we are applying two different conditions on two different fields, so we must use an AND operator with it. So here we are going to use the AND operator as well. So I'm going to apply the AND operator. This is going to be our first condition, and then you will simply place a comma here and add your second condition, which is that tags contain 20, and contain means equal to, so you are going to use the equal to operator and set it to B. So now you can see that using the AND operator, we are checking the values of two different fields at once using the exist operator. So now MongoDB is firstly going to look for all the documents where the quantity exists and the tags is equal to B, and then all the documents which satisfy both of these conditions will be fetched in the result set. Now once you hit enter, okay, so I forgot to add list symbol here because AND has a list of conditions, and place the other one here. Now it should work fine. Hit enter. Okay, so I was missing another bracket here because this is our first condition and this was the bracket of the exist condition. So now firstly it is going to check this condition which ends here, and then it is going to look for the other condition which ends here. Now hit enter, and you can see that it has returned me 4 documents, and you can verify that for all of them the quantity field exists and the tags contain the value B. So this is how you can use the exist operator in MongoDB to check the presence of a particular field inside the document. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of type operator and how you can use the type operator in MongoDB. The type operator in MongoDB selects documents where the value of a field is an instance of the specified JSON type. This operator is very helpful in querying by data type, because when dealing with highly unstructured data where the data types are not predictable and you do not have any structure of the data, that you can find different anomalies and ambiguities in your dataset on the basis of its type. Now let's quickly go ahead and see how you can use this in MongoDB. So firstly, I am going to use the command db.inventory.find to find all of the data which is present currently inside my collection. So right now I have these 7 records inside the collection. So now in order to show you the working of the type operator, I am going to add a new row inside the collection, which is going to be this document. And here I am using db.inventory.insert with function, inside which I am passing a new document where you can see that we have the quantity, but now the quantity is in the form of string inside the double quotes. Hit enter, and you can see that the document has been successfully inserted inside the collection. Let's clear the screen. Now if you want to view all the documents where the quantity field is of the specific type, then you can use the db.inventory.find function and then use the type operator inside it. So let's say that you want to find all the documents where the quantity field is of the type string. Then you can do so by applying a filter inside the find function where the quantity is, and then inside the quantity you will add the filter by using the type operator and then passing the type inside the double quote. Since I want to find all of the documents where the quantity is of the type string, so I've added it in this way, and once you hit enter, it is going to fetch a single record, which is the one that we just inserted inside the collection where the quantity is stored in the form of string. Now if you want to see that if we have any record of data type other than string, let's say int, and you hit enter, you can see that it has fetched me different documents where the quantity is stored as an integer value. Now let's say if you want to see that whether the quantity is of the type double for any of the document, hit enter, and you can see that there is no document inside the collection where the quantity type is double. So this is how you can use the type operator to find out anomalies and abnormalities in your dataset on the basis of the data type. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the expression operator and how you can use the expression operator in MongoDB. In the previous couple of videos, we have seen what are the element query operators, and now we'll move towards the next category of operators, which is the evaluation operators. There are a number of evaluation query operators that allows us to compare data and look for the relevant documents on the basis of certain conditions inside the collection. So the first evaluation query operator that we are going to explore is the expression operator. This operator allows us to create an expression statement like we make in any programming language, like if a particular value is greater than this, then what will happen, and if a value is less than this or equal to this. So these are all the expressions, and you can also create such expressions in MongoDB using the expression operator. In simple words, you can say that the expression operator allows the use of aggregation operations or aggregation expressions within the query language. So now let's see how you can use the expression operator in MongoDB. So previously, we have a collection of inventory in which we had data for the inventory of the store. But now for this video, we are going to use this data by creating a collection. So firstly, I am going to run this command db.createCollection, and I am going to create a collection called the monthly budget. So inside my Mongo shell, I am going to come back and paste the command, which is db.createCollection, and the collection name is monthly budget. Hit enter, and you will see that your collection has been created. Now if you say show collections, then it is going to display you that right now you have 3 different collections. Now I am going to copy all these statements, which are actually to insert the document inside the collection, and I am going to come back to my Mongo shell and paste these here. So here I am using db.monthlybudget.insert many, and I am inserting 5 different documents inside the collection having the fields ID, category, budget and spent. Hit enter, and you will see that 5 documents have been inserted. Now let's say that if you want to find all of the documents where the budget is either greater than the spent, or you want to find the documents where the budget is less than the spent, so you can use the expression operator to create an expression for it. And to do so, you will use the command db.monthlybudget.find, and inside it you have to provide a filter, and the first thing you have to mention inside the filter is the expression operator, because we are going to create an expression inside the filter, and then you have to provide the object. Now inside this object you have to provide 2 values where one is greater than the other. So if you want to find all the documents where the budget is greater than spent, so you are going to use the greater than operator here, and then you are going to use the list symbol, because this greater operator is going to have a list of fields. Now inside this list there is a different way of passing the fields. You have to add double quotes, and inside the double quote you have to pass the fields with the $sign. So if you want to find the documents where the budget is greater than spent, so you have to pass the budget as the first field, and if you want to have spent greater than budget, then you have to pass spent as the first field. Okay, so this is the budget. Then you have to place a comma, place double quotes again, and then inside this double quote, now you are going to pass the second field, which is spent. So in this case, MongoDB is going to generate an expression where the budget is greater than the spent, and is going to fetch all the documents that satisfy this expression. So once you hit enter, you will get two documents of ID3 and ID4 where you can see that budget is greater than the spent. You can also do this by using the less than operator, where spent is going to be the first field and the budget is going to be the second field. Now if you want to find all the documents where the budget is less than the spent, so you can simply change the GT operator with the LT operator, and now it is going to fetch all the documents where the budget is less than spent. Hit enter, and you can see that you get 3 documents where the budget value is less than the spent value. So this is a basic introduction of what is the expression operator. You can also create custom expressions having only theoretical values or numeric values inside the expression. We are going to look into it later on in this section. But that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of mod operator and how you can use the mod operator in MongoDB. The mod operator in MongoDB works in the same way like it does in any other programming language or in mathematics. So the mod operator selects documents where the value of a field divided by a divisor has the specified remainder. That is, it performs a modulus operation to select the documents. So with the modulus operator, you have to specify 2 fields. First is going to be the divisor and the second one is going to be the remainder. And if the remainder matches the field value of the document, then that document will be selected in the output. So in the previous video, I created a new collection, but right now I'm going to use the same inventory collection. So let's quickly look at the data which is present inside the inventory collection and hit enter. You can see that this is the data which is currently present inside my inventory collection. Let's clear the screen. Now if I want to find all the documents where the quantity is an even number, which means that the modulus of quantity by 2 gives 0 as remainder. So I want to fetch all of the documents where the quantity is an even number. How can you do so? You simply have to use db.inventory.find. Inside this you have to apply a filter, and the first thing inside the filter is going to be the modulus operator. So you are going to use the mod operator. Then it takes 2 values, so you are going to create a list and then define the divisor, which in this case is 2, and then the remainder, which has to be 0. And all of this value is to be applied on the field quantity. So here outside it, you have to provide quantity field. Okay, so now MongoDB is going to look for all the documents where the quantity mod 2 gives 0 as remainder, which means that the quantity is even. So once you hit enter, you will see that it has returned you 3 documents, and you can see that for all the 3 documents, the quantity is an even value. Now, if you want to find all of the documents where the quantity is odd value, then you simply have to change this 2 to 3 and hit enter, and now it is going to return the values where the quantity is odd number, but it is giving us 30, which is an even number. So let's change the condition. Change the 3 to 2 and then switch the remainder from 0 to 1. Now once you hit enter, you will see that it will provide you the documents where the quantity field is an odd number, which means that the quantity divided by 2 gives 1. So this is how you can use the mod operator in MongoDB. That's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of currentDate operator and how you can use the currentDate operator in MongoDB. Throughout this section, we are going to focus on the new kind of operator, which is the update operators. So the update operators in MongoDB process document field and acts as a placeholder to update all elements that match the array filter conditions for the documents that match the query conditions. In simple words, we can say that the update operators actually find out all the documents that satisfies a particular condition and then in turn update a specific field of all those documents. So the first update operator that we are going to discuss is the currentDate operator. So the currentDate operator sets the value of a field to the current date either as a date or a timestamp. In simple words, you can say that you will define a condition inside your update function and all the documents that satisfy the condition will be fetched, and if the currentDate operator is used, then a particular field of all those documents will be assigned a value either of the current date or the timestamp. So let's see how you can use the currentDate operator in MongoDB. So you can see that this is the data that I'm going to use for depicting the purpose and working of the update operator. So firstly, I am going to create a collection called update operator. So I'm going to copy this command, go back to my Mongo shell and paste it here. Hit enter and you will see that your collection has been created. Now if you run the command show collections, you will see that you have a new collection called update operator inside your database. Go back to your dataset and here you can see that I am adding multiple documents at once inside the collection having the fields ID, item having name and code, quantity, tags and last modified, but the last modified for all the documents is null. So I'm going to copy all of this, go back to my Mongo shell and then paste all of this here. You don't have to write all these on your own. The entire code will be available to you in the GitHub repository. So once this is done, hit enter and you will see that 5 documents have been inserted. Now, if I quickly go ahead and view the data which is present inside the collection, so I'm going to run the command db.updateOperation.find. Hit enter and you can see that this is the data which we have currently inserted, and you can see that the last modified value for all of the documents is null. Now let's see the working of currentDate operator, but let's clear the screen first. You can see that this is the data. Let's say if I want to find a document where the ID is 2, so I'm going to use ID2 as the condition inside the update function, and when that document will be fetched, then I am going to set the last modified field with the currentDate operator. So now once this document will be fetched, the last modified will be changed to have the current date or timestamp because the currentDate operator was set to last modified. Let's see how you can do this using commands. So go back to your Mongo shell. Firstly, you have to write the command db.updateOperator, and here instead of find function, you are going to use the update function because all of these are update operators. Then inside this update operator, you have to provide a filter, and this filter is going to take 2 parameters. First is going to be your condition on the basis of which documents will be selected, and the second parameter is going to be the field to which you will going to assign the currentDate operator. So if I want to find the document having ID2, so here I am simply going to define underscore ID2, and this is going to be my condition on the basis of which the document will be selected. Then inside here you have to use the currentDate operator, and then you have to define the field which will be assigned the current date. So the field is going to be last modified. So you are going to pass last modified here, and once you have written the last modified, then you are going to set it to true. So now MongoDB is firstly going to look for the document where the ID is 2, and then it is going to set the last modified value to the current date. I've placed an extra bracket here. You have to remove this one. So the update function is going to take two parameters. The first one is going to be ID or the condition on the basis of which document will be fetched and it will be enclosed in these curly braces. Then place a comma and then another set of curly braces where you are going to define that current date is set to modified date and it is true. Hit enter and you can see that match count is 1, modified count is 1 and upsetted count is 0. Now if I quickly go ahead and run the command db.updateOperator.find, hit enter and you can see that for the ID2, now the last modified is set to the current timestamp. Okay, so you can see that for the ID2, which was our condition statement, the document was fetched and its last modified value was set to the current date. Now, if you want to define some actual condition statement using the operator inside the condition part, then that is also very simple. Let's go ahead and update this command. So I'm going to just use it. Okay, so let's say that I want to update all the documents where the quantity is greater than 20, and for all those documents I want to set the last modified to the current timestamp or the current date. So this can be done by using firstly the condition, which is that quantity should be greater than 20. So I'm going to use the GT operator and define 20 here. So this is the first part of our update function. Then place a comma and then we are going to use the current date operator here. So you are going to use the current date and then inside it you are going to set the last modified to true in order to enable it. Okay, so once this is done, now let's hit enter. Okay, so I've placed equal to true instead of a colon. So now let me clear the screen first and then I am going to use the above command once again and I am going to replace this equal to with a colon, remove this and now hit enter and you can see match count is 1 and modified count is 1. This means there was only one document where the quantity was greater than 20. Now if we run the find function again and you will see that for the quantity 25 which is greater than 20, the last modified is changed to the current date. So this is how you can use the current date operator to set the value of any field to current date on the basis of a particular condition. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of increment operator and how you can use the increment operator in MongoDB. The increment operator is used to increment the value of any particular field by a specified value. It is not necessary that your field value will only be incremented by 1, but you can specify any value by which your field will be incremented. This update operator can be used for scenarios where you find the documents on the basis of certain condition and then update or increment the value of the documents field by any specific numeric value. Let's say that you want to keep track of the items inside a cart in an e-commerce application. So every time the customer adds a new item inside his cart, then you can find that document and then increment the item's value by 1 or by the number of items the user or the customer has inserted inside the cart. So let's quickly see how you can do that. Firstly, I am going to create a new collection for this purpose. So you can see that this is the data that I am going to insert in my collection. So I am going to firstly run the command db.createCollection and the collection name is going to be inc operator. Hit enter and you will see that your collection has been successfully created. Let's quickly see the collections present inside the database, and this can be done by using the command show collections. Hit enter and you can see that the increment operator collection has been created. Now I am going to copy all of these statements. Here you can see that I am adding many documents inside the collection at once. having the field ID, SKU, quantity, matrix, and inside the matrix, we have orders and ratings. Now go back to your MongoDB shell, paste all these commands here and hit enter. And you can see that 6 documents have been successfully inserted inside the collection. Now if you want to view these documents, then you can simply use the command db.incrementOperator.find, and once you hit enter, all the data which we have inserted inside the collection will be displayed. So now let's say if we want to find the document having ID 3, or let's say having an SKU value of ABC 1 to 5, and we want to increment the quantity by 2. So how can we do that? This can be done using the update function on the increment operator collection. So I'm going to use db.incrementOperator.update, but here instead of update, I'll suggest you to use the update many function. This is because if you remember that in the previous video, I used the update function and the condition inside the update was quantity greater than 20. And if you remember that we have more than one document having quantity greater than 20, but since I used only the update function, so only a single document's value was updated. So if you have doubts that there may be more than one document which satisfy the condition and may be updated, so you have to use the update many function instead of single update function. So now inside the update many function, the first parameter is going to be the condition that SKU is ABC 1 to 5. So I'm going to write SKU is, and inside double quotes you have to pass ABC 1 to 5 because it is a string value. Then you have to define which field is to be incremented. So you are going to use the increment operator, place a colon, and then we want to increment the quantity. So you are going to use the quantity and then set it to true. So now MongoDB is going to look for the documents where the SKU is ABC 1 to 5, and then it is going to increment the quantity field by the specified value. So here instead of true, you have to provide the value. Since I want to increment the quantity by 2, so I am going to add it to 2. You can add here any value which you want to increment the field. Now let's hit enter, and you can see that one document matched our condition and modified count is also 1. Now if you run the command db.incrementOperator.find, you will see that for the SKU ABC 1 to 5, now the quantity is 12 instead of 10. So this is how you can use the increment operator in MongoDB to increment a particular document's field value by a specified number. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of decrement operator and how you can use the decrement operator in MongoDB. The decrement operator decrements a particular field's value of a document by a specified number. It is not necessary that the field must be decremented by 1. It may be any value that the user specified. It is exactly like the increment operator, with the difference being that the increment operator, the value is added to the field of the document, but in decrement operator, the value will be decremented from the field of the document. So this is the data that I am going to use in this video. In the previous video, I created a collection called increment operator where there are 6 documents. So out of this data, if I now want to update the document having an SKU of ABC 1 to 7 and decrement the orders inside the matrix by 5. So how can you do this? Go back to your MongoDB shell, and here you have to write the command db.incoperator.update, and then inside this function you have to pass 2 parameters. The first parameter is going to be the condition, which in this case is SKU. So the SKU value is ABC 1 to 7. So now I am going to pass ABC 1 to 7 inside the double quote since it is a string value. Then place a comma, and then you have to define the field which needs to be decremented. So firstly you are going to use a decrement operator, and then you are going to define the field. So you can see here in the data set that this orders field is present inside the matrix. So you are going to use inside the double quote matrix dot orders, close the double quotes, and you want to decrement it by 5. So now firstly MongoDB is going to look for the document where the SKU value is ABC127, which is the ID 5, and then it is going to decrement the matrix.orders value by 5. So right now for the ID 5, the orders value is 22. So after decrement, it must be 17. Let's hit enter to verify. Unknown modifier. Okay, so I think the decrement operator is deprecated in the current version of MongoDB because I'm using the latest version. So I have another option. Let's write this once again, and you should know that the increment operator takes both the positive and the negative values. So we are going to change the decrement operator to increment, and here instead of simple 5, I am going to pass -5. Now hit enter and you can see that match count is 1, modified count is 1 and upsetted count is 0. Now if I quickly go ahead and run the command db.incrementOperator.find and hit enter, you will see that for the ID 5 where the SKU is ABC127, you can see that the matrix orders value is now 17 instead of 22. So this is how you can use the decrement operator in MongoDB. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of min operator and how you can use the min operator in MongoDB. The min operator or the minimum operator is also a kind of the update operator. The minimum operator updates the value of the field to a specified value if the specified value is less than the current value of the field. Moreover, the minimum operator can compare values of different types using the BSON comparison order. So let's say you have a document where the value of a field is 50 and you want to pass a new value to the field. Let's say the new value is 30. So now the min operator is going to test whether the current value of the field is less than the new value or not. So if the current value is less than the new value, then the min operator will keep the current value of the field as it is. But if the new value of the field is less than the current value, then the field value will be updated to the new value. So whichever one is the minimum will be assigned to the field. So this is the data that I'm going to use in this video. Firstly, I'm going to create a new collection. For that, I am going to run the command db.createCollection, and the collection name is going to be min operator. Hit enter and you can see that your collection has been created. Here you can see that I am inserting multiple documents inside the collection at once, having ID, high score and low score. So now I am going to paste all these commands and hit enter, and you can see that the data have been successfully inserted inside the collection. Now let's quickly see the working of min operator in MongoDB. So you simply have to use db.minOperator.update function, but not simple update. You have to use update many because there might be more than one document that satisfy the condition and have to be updated. Then inside the update function, firstly you have to define the conditions like any other update operator. So the condition is that I want to update the ID2 document. So I am going to pass underscore ID is 2, and then in the next bracket you have to define the new value for the minimum operator. So let's say that for ID2 the new high score is 450. Okay, so I am going to say minimum, and inside this I am going to say high score is 450. So now MongoDB is going to find the document where the ID is 2, and then it is going to compare this new high score with the high score value that it currently has. So if this value is less than current value, then the field value will be updated to this value. So let's hit enter and you can see that modified count is 1. Now if I quickly go ahead and run the command db.minOperator.find and hit enter, you will see that now for ID2 the high score is changed to 450 instead of 500 because the value that we passed with the min operator was less than the current value. Now if I try to change another value, let's say for the ID 3, I'm going to pass the high score to be 950. So the current high score is 850 and I'm passing the high score to be 950. So whichever is the smallest one will be assigned to the field. Hit enter and you can see that match count is 1 but modified count is 0. This means nothing has been modified. Now if you quickly run db.minOperator.find, you will see that for the ID 3 the high score is still 850 because the current value of high score was less than the new value. So this is why it kept the current value as it is. So this is how you can use the min operator in MongoDB. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of max operator and how you can use the max operator in MongoDB. So the max operator or the maximum operator in MongoDB is also a kind of update operator. The max operator updates the value of a field to a specified value if the specified value is greater than the current value of the field. The maximum operator can compare values of different data types using the BSON comparison order. So it is very much similar to the minimum operator, but the minimum operator selects the smallest value while the max operator selects the greatest value or the maximum value. So I am going to use the same data which I used in the previous video. So let me quickly show you what is present inside the collection. The collection name is min operator. So I'm going to run the command db.minOperator.find. And once you hit enter, you will see that this is the data which is currently present inside the collection. Now let's say if I want to check the high score of ID 3, I can use the command db.minOperator.update and update many. And I've already mentioned why you should use update many instead of update and update one. So now firstly comes the condition. So the condition is that ID is 4. So I'm going to pass a condition, place a comma, and then you have to define the new value with the max operator. So I'm going to firstly use the max operator and then inside the brackets you have to pass the value. So I'm going to say that high score new value is 400. Once I hit enter, the MongoDB is going to go inside the collection and find the document having the ID 4. Then it is going to compare this high score value to the current value of the high score field, and whichever is greater, then that value will be assigned to the high score. Hit enter and you can see that match count is 1, modified count is 1. This means that something has been modified. Now if I again run the command db.minOperator.find, you will see that for the ID 4, the high score is now 400 instead of 60 because we passed 400 with the max operator as the new value and 400 is larger than 60. So that is why the new value assigned to high score was 400. So this is how you can use the max operator in MongoDB. That's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of mul operator and how you can use the mul operator in MongoDB. The mul operator or multiply operator in MongoDB is also a type of update operator. The mul operator updates the value of a field by multiplying it with any constant number. So I'm going to use the same dataset which I've been using in the previous two videos. So let's quickly go ahead and see what is the data which is present inside the collection. So my collection name is min operator. I'm going to run the command db.minOperator.find. Hit enter and you can see that this is the data which is currently present inside our collection. So if I want to update this low score by multiplying it to 2, which means that I want to update the low score to double. So that can be done by multiplying it by 2. This can be done by using the mul operator. So all you have to do is you have to run the command db.minOperator.update many because there may be more than one document which will satisfy the condition present inside the update function. So the condition is going to be that ID is 3. So here firstly I am going to pass that ID is 3. Then you have to provide the field whose value you want to update using the mul operator. So firstly you are going to use the mul operator and then you are going to define that you want to update the low score by multiplying it by 2. So now firstly MongoDB is going to find the document where the ID is 3 and then it is going to multiply the low score value by 2 and assign it to low score. Hit enter and you can see that match count is 1 and modified count is 1. Now if I again run the command db.mainOperator.find and hit enter, you will see that now for the ID 3 low score is 400 instead of 2. This is because we multiplied it by 2 and the updated value is assigned to the low score. So this is how you can use the mul operator in MongoDB. That's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of rename operator and how you can use the rename operator in MongoDB. So the next update operator that we are going to discuss is the rename operator. So the rename operator is used to change the name of any field present inside the document, and that field may be a main field or a nested field inside a field. This operator is particularly useful when you have a typo while inserting the field inside the document and then you want to change the name of the field to make it correct. So now let's quickly see how you can use the rename operator in MongoDB. So firstly, I am going to use this data set for this purpose. So firstly, I am going to create a new collection by the name rename operator. Copy this, I'm going to come back and paste it here. So I'm going to use the command db.createCollection and the collection name is rename operator. Hit enter and your collection has been created. Now you can see that I am inserting multiple documents at once inside the collection, but if you notice that here the spelling of the name is wrong in all the 3 documents. So I am going to use the rename operator to correct this field. Before that, let's copy all of this and you can get the code from the GitHub repository. Go back and paste it here, and once this is done, hit enter. Okay, so I forgot to add db. It has to be db. Let's paste it again. And now we have db here. Hit enter and you can see that 3 rows have been inserted having ID 1, 2 and 3. Now let's clear the screen. As I've already told you that here the name spelling is wrong in all the 3 documents and I want to change the spelling of this field, which can be done by using the rename operator. So I'm going to come back to my MongoDB shell and I'm going to use the command db.renameOperator.update because it is an update operator, and here instead of update I am using update many because I want to update many documents at once. Then the first thing that you have to define is the conditions. Since I want to update the name field in all the documents, so I'm not going to specify anything inside the condition and I'm going to leave it empty. Then the next thing is to use the operator. So firstly, I'm going to use the rename operator, and then you have to define that you want to rename which field. So I want to rename this NMAE. So I'm going to use the same spellings here and I'm going to change it to NAME. Let's enclose both of these in double quotes since it is a string. Once you hit enter, you will see that MongoDB is going to look for no particular document, rather all the documents, because the condition is empty, and it is going to rename the field NMAE to NAME. Okay, now let's hit enter and you can see that match count is 3 and modified count is 3. Now if you go ahead and run the command db.renameOperator.find and you hit enter, you will see that now we have the correct spelling of the name field in all the 3 documents. Now let's say that if you want to update the field which is nested inside another field, let's say I want to change this first and last to F name and N name to define that it is the first name and last name, and these 2 are nested inside the name field. So how can you do that? To do so, you have to use the command db.renameOperator.update, and once you are inside the function, again we are going to leave the condition field empty because we want to apply this on all the fields of all the documents. So I'm going to use update many as well, and then here I'm going to firstly use the rename operator, and then you have to define that which field you want to update. So inside the double quotes you have to pass name dot first, and you are going to update it to, and the updated value should also be inside the double quotes, as you want to update it to name dot fname. Okay, so this is to rename the one field. If you want to update two fields at once, so simply place a comma here and then add again double quotes, and then you will say name dot last, and then come out of it, place a colon, and inside a set of double quotes you are going to call it name dot lname, because it is present inside the name field. So now MongoDB is going to fetch all the documents and then rename the field name dot first to name dot fname, and then fetch the field name dot last and rename it to name dot lname. Okay, so once this is done, hit enter. You will see that mesh count is 3 and modified count is 3. Now if I quickly go ahead and run the command db.rename_operator.find and hit enter, you can see that now instead of first and last, it is giving me fname and lname. So this is how you can use the rename operator in MongoDB to rename the fields of document. That's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what is the purpose of set operator and how you can use the set operator in MongoDB. So the next update operator that we are going to discuss is the set operator. The set operator has a variety of functions that we can perform using it. But overall, the set operator replaces the values of a field with the specified field. And that field may be a parent field or a nested field. And you can use it to perform a large number of operators. I am going to cover most of them. So let's quickly see how you can use the set operator in MongoDB to set the values of different fields inside the document. So this is the document that I'm going to insert inside the collection. So firstly, let's create a collection by the name set operator. I'm going to copy this command, go back to my Mongo shell, and I'm going to paste it here. Hit enter and your collection has been created. Now you can see that here I am inserting a single document having the following fields inside it, and you can see that some of the fields also have nested fields in them. Now let's go back to your Mongo shell, paste all the commands here and hit enter, and you can see that your document having the ID 100 has been inserted. Now let's say if you want to change the quantity value from 250 to 300, then this can be done by using set operator in MongoDB. So all you have to do is you simply have to use the command db.setOperator.update many, and then inside this you have to firstly define a condition. Since we have a single document and we want to update the field of that document, so I'm going to leave the condition field as it is, and then firstly you are going to use the set operator. Then inside the object you have to define the field which you want to update. So I want to update the field quantity, so I'm going to pass it and set the new value. So now I am changing the quantity field from 250 to 300. Now once I hit enter, MongoDB is going to go inside the document, go into the quantity field and set its value to 300. Hit enter and you can see that mesh count is 1, modified count is 1, and upsetted count is 0. This means that one record has been updated. Now if you want to view the updated data, you can simply run the command db.setOperator.find. Hit enter and you can see that now the quantity is updated to 300 instead of 250. Now let's say if you want to alter the detail field of the document, so you can do so by using the command db.setOperator.update many. Then leave the condition field as it is, and in the second bracket you have to firstly apply the operator and then you have to provide the field. Now I want to update the details field. I'm going to pass details here. Then here I'm going to firstly change the model to model 2, and I'm going to pass it the value of 1, 2, 3, 4 in the form of a string. And then the next field inside the detail is make, so I'm going to call it make2, and I'm going to pass the value xyz for it. So once this is done, hit enter and you can see that match count is 1 and modified count is 1. Now if you run the command db.setOperator.find and hit enter, you will see that previously the details contain model and make having the following values, but now the details contain model2 and make2 and the new values that we set by using the set operator. So you can see that it has updated not only the fields inside the detail field but also the values of the field. Now if you want to set the values for the tags field, so you can again run the command db.setOperator.update many. And now firstly we are going to leave the condition field to empty, and then for the set operator we are going to set the tags. So inside the brackets I am going to pass tags here, and since the tags has a list of fields or a list of values, so I am going to pass different list here. Let's say 1, 2, 3, 4, 5. And these are the values for the tags. Hit enter and you can see that modified count is 1. This means that something has been updated. Now if I quickly run the command db.setOperator.find once again, you can see that the tags value, which was previously these two values, has been updated to integer values. This means that not only the value of the field inside the tags is changed, but also the data type is changed. But now let's say that if you want to update the value of this model2 inside the details, then this can be done by using the set operator as well. All you have to do is leave the condition part, and inside the set operator, since the model2 is present inside the details, so we are going to access it like so: details dot model2, then place a colon, and then you have to provide the field which is going to be, let's say, ABCD. So we are going to change the model in this way. Hit enter and you can see that one field has been updated. If we quickly view the data, you can see that now for the value of model2, which was previously 1, 2, 3, 4, now it has been updated to ABCD. So this is how you can use the set operator in MongoDB to set the values of the fields and the nested fields as well. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm gonna show you what is the purpose of unset operator and how you can use the unset operator in MongoDB. So the next update operator that we are going to discuss is the unset operator. The unset operator is used to remove a particular field from a document, and you can also remove any field from all the documents at once by leaving the condition part empty. So I'm going to use the same data set that I used in the set video. Let's quickly see the data which is present inside the collection. So I'm going to use the command db.setOperator.find, and this is going to fetch all the documents which were present inside the collection. So let's say if I want to remove the reorder field from this document, then how can you do that? This can be done by using the command db.setOperator.update, and here you can simply use update as well because we have a single document inside the collection. And then inside this function you have to provide a condition and the operator. So I'm going to leave the condition part empty because I have the single document and I want to update its field. Then you have to apply the operator, which in this case is going to be unset, and after the unset operator you have to provide the field which you want to unset. So I'm going to unset the reorder field, so I'm going to pass reorder here and then leave it empty. So MongoDB is going to go inside the document and is going to unset the reorder field. Now if you hit enter, you can see that modified count is 1. This means that something has been updated. Hit enter and you can see that now we do not have the reorder field because we have unset it using the unset operator. Now if you want to unset a particular field inside the object, which means a field which is nested inside another field, let's say we want to unset the model2, how can you do that? It is very simple. You simply have to use db.setOperator.update function, leave the condition part as it is, then inside the next part use the unset operator, and then here since it is a nested field, so you have to use the double quotes, and then you have to write detail dot model2, and then come out of the double quote, place a colon and leave the field empty. So now hit enter and you can see that one object has been updated. If you quickly view all the data, you can see that now details has only one nested field, which is make2, because make1 has been unset or removed using the unset operator. So this is how you can use the unset operator in MongoDB to remove any field from a document. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm gonna show you what is the purpose of pop operator and how you can use the pop operator in MongoDB. Just like you can use push and pop operation to insert or remove element from the stack in any programming language, same is the case with the pop operator in MongoDB. The pop operator removes the first or the last element of an array, and you cannot interact with any other element of the array using the pop operator. It only interacts with the first and the last operator in order to remove it. It takes two values, either you can pass it -1 or +1 or simple 1. You can pass pop operator a value of -1 to remove the first element of the array, and you can pass 1 to the pop operator to remove the last element in an array. So let's quickly see how you can use the pop operator in MongoDB. So this is the data that I am going to use. Firstly, I'm going to create a new collection by the name pop operator. So I'm gonna go back to my Mongo shell and paste the command here and hit enter. And you can see that my collection has been created. Now if I run the command show collections, it is going to show me that in addition to all other collections, a pop operator collection has also been created. Now you can see that here I am inserting a single document inside the pop operator having the ID 1 and containing an array of scores having 4 elements. So I'm going to copy it, go back to my Mongo shell, and I'm going to paste it here. Hit enter and you will see that one document has been inserted. Now if you quickly go ahead and run the command db.popoperator.find to view the data which is present inside the collection and hit enter, you can see that we have one document having ID 1 and an array of scores. Let's clear the screen. Now if you want to remove the first element of the array using the pop operator, then you will simply have to pass -1 to it, and it is going to remove the element from the array. Let me show you how. So you have to run the command db.popoperator.update because it is an update operator. You can also use update many as well. So I'm going to use the same, and once I'm inside the function, I'm going to leave the condition part empty because right now I have only one document and I want to remove the first element from that document's array. Then for the next part, firstly you have to define the operator, which is the pop operator, and then you have to define the array name from which you want to remove the element. So the array name in this case is stores. So I'm going to pass stores here, and I'm going to pass the value -1 to it. So this -1 will indicate that we want to remove first element from the array stores inside the pop operator collection. So now once I hit enter, you will see that match count is 1 and modified count is 0. Okay, this is because the array name was scores and I wrote stores. Okay, now update it to scores and hit enter, and you can see that now match count is 1 and modified count is 1. Now if you quickly go ahead and run the command db.updateoperator.find and hit enter, you can see that now you only have 3 elements inside the scores array, and the first element has been removed because we passed -1 with the pop operator. Now if you want to remove the last element from the array of scores, you can do so by using 1 with the pop operator. Here you will have to simply change the -1 to 1. And once you hit enter, you will see that match count is 1, modified count is 1. This means that one element has been updated. Now if I run the command db.popoperator.find, you can see that now instead of 3 values, now the array has only 2 values because the last one has been removed. So this is how you can use the pop operator to remove the first and the last element of the array inside a document. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I am going to show you what is the purpose of pull operator and how you can use the pull operator in MongoDB. In the previous video, you have seen that how you can use the pop operator to remove only the first or the last element of an array. In this video, we are going to see how you can use the pull operator in MongoDB. So the pull operator is used to remove any particular element from an array inside the document that matches the specified condition. So all the document where the element of an array field matches a specified condition, then all those elements will be removed from all the documents in which they are present. So in this way, you can interact with different elements inside the array instead of just the first and the last one. So this is the data that I am currently going to use. So firstly, I am going to create a new collection by the command db.createCollection, and the name of the collection is going to be pull operator. So go back to your Mongo shell and paste the command here. You will get this code from the GitHub repository. Hit enter, you can see that the collection has been created. Now if you run the command show collection, it is going to show you that a new collection called the pull operator has been created. Here is the data that I want to update. You can see that I am inserting two documents at once inside the collection having two fields, ID and scores is an array of different score values. Copy all of this, go back to your Mongo shell and paste it here. Hit enter, and I didn't copy DB. Let's go here and put D here. Now once you hit enter, you can see that two rows have been successfully inserted inside the collection. Let's clear the screen. Okay, so this is the data. If I want to remove the score value having value of either 2 or 4 using the pull operator, then how can you do that? Go back to your Mongo shell, and here you have to run the command db.pullOperator.update many, because more than one document will be updated as a result of our pull operator. And in here you have to define two different conditions. The first condition is going to be used to select the documents, and the next condition is to be placed on the field of the document whose value you want to remove. So I'm going to leave the first condition empty because I want to select all the documents, and then I want to remove the value 2 or 4 from the array of score. So firstly, here I am going to use the pull operator, and then inside it I am going to define the array name, which is scores, and I want to remove the score values either 2 or 4. So here once again I am going to use another operator, which is going to be the in operator, and with the in operator I am going to pass two values, which is 2 and 4. So now MongoDB is going to go inside the pull operator collection, and we'll see that we are selecting all the documents, and it is going to remove all the values from the scores array which are either 2 or 4. So once you hit enter, you will see that match count is 2 and modified count is 2. Now if you go ahead and run the command db.pullOperator.find and hit enter, you can see that now the first document has two values for the score 1 and 3, and the ID 2 has score 55. So if I see the initial data, you can see that for the first document we had 1, 3 and 4, but we want to remove the value 4, so now it has been removed and only 1 and 3 are remaining. And for the document 2, we have 4, 2 and 55 as the score, and we wanted to remove the values 2 and 4, so only 55 is remaining. So this is how you can use the pull operator to remove any element from the array field which satisfies the specified condition. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm gonna show you what is the purpose of push operator and how you can use the push operator in MongoDB. The push operator in MongoDB works in the same way just like it works in the stack in different programming languages. But the difference is that the push operator in MongoDB is going to insert an element inside an array in the end and not on the top. But in case of different programming languages, when we use the push operation on the stack, it pushes a new element on the top of the stack. But in case of MongoDB, it is going to insert a new element at the end of the array. So let's see how you can use the push operator in MongoDB. So this is the data that I'm going to use. Firstly, I'm going to create a new collection by the name push operator. I'm gonna go back to my Mongo shell and paste it here, hit enter, and you can see that the collection has been created. Now if I run the command show collections, you will see that I have a push operator collection as well. I'm going to insert the same data that I used for the pull operator. So I'm going to copy this, go back to my Mongo shell and paste it here. And you can see that the data has been successfully inserted. Now let's clear the screen. If I want to add a new value to both the documents, then I'm going to simply use the push operator and specify the condition. Let's see how you can do that. You simply have to use the command db.pushOperator.update many, because it is going to update multiple documents at once. And inside the update many function, you have to specify two conditions. The first condition is going to be the condition on the basis of which you want to select the document, and the second one is going to be the condition on the field inside which you want to insert a new value. So right now we want to insert the new value in all the documents, so I'm going to leave the first part as it is, and then for the second part you have to firstly define the operator, which in this case is the push operator, and then you have to define that in which field you want to add the value. So the array name is scores, and I want to insert the value of, let's say, 10. So now MongoDB is going to go inside the push operator collection and is going to insert a value of 10 inside the scores array in all the documents. Hit enter and you can see that match count is 2, modified count is 2. Now if you go ahead and run the command db.pushOperator.find and hit enter, you will see that a value 10 has been added at the end of both of the arrays inside the documents. And if you want to insert value in any particular document, then instead of leaving this part empty, you can define a condition, let's say, where the ID is equal to 2. So I'm going to use the equal to operator here, and I'm going to say that the ID equals 2, and I want to push a value, let's say 45. Okay, hit enter and you will see that now match count is 1 and modified count is 1. If I run the command db.pushOperator.find once again, you will see that the 45 will be added to only the document having the ID 2. So this is how you can use the push operator in MongoDB to insert elements at the end of array field. So that's all for this video. I'll see you in the next one. In MongoDB, data modeling is the process of designing the structure and organization of data within the database to meet the requirements of your application. Data modeling involves defining how data will be stored, organized, and accessed in MongoDB, which is a NoSQL database that stores data in a flexible, schemaless format known as BSON format. Data modeling in relational database and NoSQL database, which is MongoDB, is very different from each other, but both of them have certain similarities as well. So the first similarity is that both of the models have a common thing, which is the database. So the database is the root structure inside which you can add different components. Then come some differences between the relational data model and the NoSQL data model. In relational data model, we have tables which are present inside the database. That is, each database has multiple tables inside it. On the other hand, in NoSQL data modeling, we have different collections, and a database contains a set of multiple collections inside it. So a table in relational model corresponds to a collection in the NoSQL model. Another main difference is that in relational data modeling, a table has a particular schema, which means that it is already defined that which type of data will be added to the table and what will be the fields. But in NoSQL modeling, the collection is schemaless. This means that there is no specific defined schema of what type of data can be stored in the collection. Then in relational modeling, we have rows inside the tables which contain the actual data to be placed inside the table. Whereas in NoSQL modeling, we have document which may either be in the JSON or the BSON format, and that document corresponds to a row in the relational model. So just like a row contains all the data present inside the relational model, in the NoSQL model, a document contains all the data which is present inside the collection. Then in the relational model, we have columns that specifies what data is placed in each of the row, whereas in the NoSQL model, we have different fields in the form of key value pairs. So a table consists of a combination of rows and columns, and a collection consists of documents which have different fields. In this image, you can see that we have a relational database having 5 tables: people, articles, comments, tags, and categories. You can see the fields which are present inside all the tables and the relationship between them. So the people's table and the articles table have a one-to-many relationship. Same is the case for people to comments, and same is the case for articles to comments. Since one article can have multiple comments, so there is one-to-many relationship. But in case of articles and tags, since many articles can have many tags and many tags can be in many articles, so there is many-to-many relationship, and same is the case for articles with categories. Here you can see the translation of the relational database into MongoDB, and you are provided with 3 different options. The first option is that you can convert each of the table present inside the relational database to a collection in MongoDB, since a table corresponds to collection in MongoDB. So here you can see that in the first part, we have 5 different collections that corresponds to the tables in the relational database. The second option is to embed the collections into each other to show the relationship. That if you remember, in the relational database, articles and people have one-to-one relationship, and article with tags, categories, and comments has one-to-many and many-to-many relationship. So if we choose the embedded collections option, you can see that we have the main collection of the articles, and we have embedded the people collection, the comments and tags inside it, and the comments, tags, and categories. Since it has many-to-many relationship with the article, so we have created an array of all of these inside the articles collection to depict the relationship. And the third option is that you define 2 different collections. One is going to be of the people, and the other one is going to be the articles, and the articles collection will have an array of tags, categories, and comments to show that articles, tags, categories, and comments have many-to-many relationship, and the people's collection and the articles collection have one-to-many relationship. So these are some different ways of translating the relational database into a NoSQL database. There are 3 kinds of relationships in MongoDB: one-to-one, one-to-many, and many-to-many. We can represent these relationships using references or embedded data. So let's first see how we can represent the relationships using references. Here you can see that we have 3 different documents: employee document, address document, and contact document. In the employee document, we have ID, employee name, and age. In the address document, we have ID, which is the primary key of that document. Then we have city, country, and we also have the employee ID, which refers to the ID of the employee in the employee document. Then we have the contact document, where we have ID, mobile number, and email, and it also have employee ID as well, which refers to the ID of the employee document. So you have actually provided a reference to the employee document inside your contact document and the address document. So this is how you can show the relationship using references. Now let's see how you can show the relationship using the embedded data. Here you can see that we have a single document called employee document, and inside it we have ID, employee name, and age, and then we have another document embedded as a sub-document inside the employee document called the address, having city and country, and then we have another document called the contact document, which is embedded as a sub-document in the employee, having mobile number and email ID. So this is how you can show the relationships using the embedded data. And that's all about data modeling. That's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can represent one-to-one relations in MongoDB using the embedded documents. Let's say we have a customer collection and we want to store the contact details of all the customers. In the contact details, we want to store the email and phone number and fax number of each customer. Now each customer is going to have a unique email and phone number, and user is also going to have a single contact detail. Here we do not want to store multiple contact details for a single customer. So in this example, each customer has a single contact detail and the contact detail cannot be same for two or more customers. So here we want to create a one-to-one relationship between the customer and his contact details, and this is a perfect example where we can use the embedded document for creating a relation, because here since each customer is going to have a unique contact detail, we are not going to have a redundant or duplicate data in the customer collection. So let's quickly see how you can actually implement the one-to-one relationship in MongoDB using embedded documents. So here is the data which I am going to use. Firstly, I have a customer collection where I have two documents having name, age and from field, and the from contains both the city and the country. Then I have a contact collection in which I have the contact information of the customers having ID, email and fax. And since each customer can have only one contact, so this means that they have a one-to-one relationship, and embedding the documents will be a suitable way to show the one-to-one relationship in this case. So let's quickly go ahead and create a new collection. And to do so, I'm gonna run the command db.createCollection, and I'm going to pass the name customers inside the collection to create a collection by the name customer. Hit enter and you can see that your collection has been created. Now if I quickly run the command show collections, you can see that the customer collection has been created. Now if I want to simply create customer collection, I can copy all of this and paste inside the MongoDB shell, and the following documents will be inserted inside a collection. But we want to embed the contact collection inside the customer collection, so we are going to place a comma here. I'm gonna go inside my contact collection, copy all of this from here, and I'm gonna come back and insert a new field called contact here, and this field is going to contain this data having ID, email and fax. Let's change its indentation a bit so you can understand that these are part of the contact document. Okay, so this is done. Now let's go back for the second one. Copy all of this from here. Go back to your document. Place a comma here. Go to the next line. Here I am going to add a new field called contact. Place a semicolon. And then I am going to paste it here. I am going to add a new opening bracket and a closing bracket for here. So now you can see that we have embedded the contact document inside our customer document to show the one-to-one relationship. Now let's quickly copy all of this. I'm gonna go back to my Mongo shell and I'm going to paste all of that here. Once this is done, hit enter and you can see that two documents have been successfully inserted. Now, if you quickly go ahead and run the command db.customer.find and hit enter, you can see that you have two documents having ID, name, age, from, and then you have the contact document having ID, email, and fax of each customer within its document. So this is how you can show the one-to-one relationship between two collections by using embedded documents. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm gonna show you how you can depict the one-to-many relationship in MongoDB using embedded documents. Let's say we have a customer collection. In the customer collection, we are storing all the customers and each customer is going to have a payment method. For example, a customer can add different cards for doing the payment. Let's say that customer 1 has added 3 payment methods. Basically, he has added 3 different cards in the payment details using which he can make the purchase. And customer 2 has added only one payment method. He has added only one card through which he can make a purchase. So this is an example of one-to-many relationship. One customer can have multiple payment methods, but two customers cannot have the same payment method. So this is one example of one-to-many relationship. One customer can have many payment methods, and this is one such scenario where we can use the embedded documents for creating this one-to-many relation. Why? Because a customer is not going to have a lot of payment methods. A customer can have maximum 10 or 15 payment methods. He can add 10 or 15 cards. He's not going to add 100 or thousands of cards for making the payment. So now let's quickly see how you can actually implement the one-to-many relationship in MongoDB using the embedded documents. So if I go ahead and run the command db.customer.find, you can see that right now I have two documents having name, age, and from, and an embedded document contact from the previous video. Now I am going to update both of these documents one by one to embed the payment document inside it in order to show that customer and payment have one-to-many relationship. So for that I am going to run the command db.customer.update1 because I am going to update each document one by one. Then inside it, firstly you have to provide the selection condition. So I am going to say where the name is John. So this is going to select our first document. Then you have to provide the other condition. And for that I am going to write this statement. Here firstly I am using the set operator to set the payment method. So this payment method is a new document that I am embedding inside my previous document inside the customer collection. And this payment method has two fields inside it in the form of an array having card number and an expiry date. So once this is done, hit enter and you can see that match count is 1, modified count is 1. Now I am going to do the same for the second one. So for that I am going to change the condition from John to Mark in order to update the second document, and I am going to change the payment method to a few digits in order to change the ambiguity or redundancy, and I am going to add only one payment method in this case. Oops, I accidentally hit enter, so I was actually removing this second payment method from here. So John is going to have two payment methods, but Mark is going to have a single payment method. Okay, now let's hit enter and you can see that match count is 1, modified count is 1. Now if you go ahead and run the command db.customer.find, you will see that you have two documents. For the first document you have customer name, age, from, contact, and then you also have an array of payment methods having card number and expiry date as its field. And then for the Mark you have a single payment method. So in the first document you can clearly see that one customer can have many payment methods. So this is how you can show the one-to-many relationship in MongoDB using embedded documents. That's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can establish a one-to-many relationship between the collections using references. In the previous video, you saw that a customer can have many payment methods, but the payment method cannot be hundreds or thousands. So in order to show the one-to-many relationship between the customer and the payment method, we use the embedded document approach. But what if we want to establish a relationship between a customer and an order? So a customer can place hundreds or thousands of orders from our application. So in this scenario, if we use the embedded document approach, then embedding hundreds and thousands of orders inside a single customer might be very messy, and it will also make querying very difficult. Moreover, the individual document size might also exceed 16 MB, which is not admissible in MongoDB. So in the case of customer and orders one-to-many relationship, we cannot use the embedded document approach. So in order to display this one-to-many relationship, we are going to use references. As discussed earlier, you can use the references approach to show the relationship between the two documents by adding the ID of one document inside another to create a connection or relationship between them. So in the previous video, you remember that I created a collection called customer in which I added the data and created its relationship with the payment method. Now let's quickly go ahead and run db.customer.find function to see what is present inside our customer collection. So you can see that right now we have 2 documents inside it having ID, name, age, from, contact and payment method information. Now I am going to create a new collection called orders. So I'm gonna run the command db.create collection and the name of collection is going to be orders. Once this is done, hit enter and you can see that your collection has been created. So this is the data that I am going to insert inside my orders collection. You can see that each document has an ID, a date in which I am assigning a new date object having the date value as string, and then I am providing product ID, which is an array of values because one single order can have more than one product inside it. So right now I am inserting 5 documents at once inside the collection. So let's copy all of this. You will get this code from the GitHub repository. Go back to your Mongo shell and paste it here. Once this is done, hit enter and you can see that 5 documents have been successfully inserted. Now if I go ahead and run the command db.orders.find to see what is present inside our orders collection, you can see that we have 5 documents having ID and the date has been converted into ISO date and an array of PIDs present for all the documents. Now we want to show the one-to-many relationship between the customer and the orders using the references approach. So how can you do that? Since a customer has orders, so we are going to update the customer's document and add the references of the orders inside each document. So for that, you are going to update the customer's collection. I'm going to use db.customer.update many because we may update more than one document at once. Okay, then inside this, firstly we have to define the condition. Let's say I want to update the customer document where the name is Mark. So I am going to say Mark and then we have to define the updation. So here I want to add a new field inside this customer's document. So I am going to use the set operator and here I am going to create a new field. I'm going to call it orders. And the orders is going to have an array of numeric values because one customer can place multiple orders and the orders are going to contain different order IDs. So let's say the orders IDs are 1, 3 and 5. Okay, so now MongoDB is going to go inside the customer collection and will find the document where the name is Mark and is going to set a new field named orders having value 1, 3 and 5 inside the document. Hit enter and you can see that one document has been updated. Now let's quickly go ahead and change the condition so that the document having the name John will be updated. And now I am going to set the values of orders to 2 and 4. This is because no 2 orders can have the same order ID and no 2 customers can have the same order ID. So the order ID is unique for each of the order and so each customer cannot have orders having the same order ID. This is why I cannot pass 1, 3 or 5 here. I have to choose the remaining 2 orders. Now hit enter and you can see that your document has been updated. Now if I go ahead and run the command db.customer.find, I'm going to change it to customer and hit enter. You will see that now an additional field has been added inside your document depicting the order ID 2 and 4 are placed by this customer. Now let's quickly go ahead and use the lookup operator on the customer collection to join it with the orders collection. And for that you have to write db.customer.aggregate. Inside the aggregate function, you have to pass an array and inside this array, you have to pass the lookup operator. Here, the lookup operator performs an equality match on the foreign field to the local field from the input document. So, we can say that in the customers table, the orders might be a field through which we can match the documents inside the orders collection. After using the lookup operator, you have to provide the collection name from which you want to get the data by using the from keyword. So we want to get the data from the orders collection, so I'm going to pass it here. After that, we have to define the local field. So local field is a field which is actually containing a reference to the related collection. So the customer collection has a field that references to the orders collection, and that field is orders. Let's enclose the orders in double quotes since it is a string value. And after that, you have to provide a foreign field as well. So the foreign field is like a foreign key. So the foreign field is the field which we are using for creating the relationship. So in simple words, you can say that for the foreign field, you have to provide the field name on the basis of which you are creating a connection between the customer collection and the orders collection. So if you remember that inside the customer table, we have a field of orders which contains an array, and that array contains order IDs which are present inside our orders collection. So here inside the foreign field, we have to provide the field name on the basis of which we are establishing a connection, which in this case is the ID from the orders collection. So I'm going to define underscore ID here in double quotes, and then we have to provide an alias by which we are going to see the new field. So I am going to call it order details. So you need to change one more thing. Here instead of a square bracket, you have to use the curly braces and also change it here. So now MongoDB is going to go inside our customer collection, and it is going to join it with the orders collection via the lookup operator. And with the lookup operator, we have to define the local field, foreign field, and an alias. So local field is the field name inside the customer collection which contains the data on the basis of which we are establishing a relationship with the orders. So here the local field was orders, and for the foreign field you have to provide the field name which is present inside the local field. So the orders field in the customer actually contains an array of order ID. So we are going to pass underscore ID here, and then we have provided an alias. Now let's hit enter. Okay, so it is saying that orders is not defined. Okay, so here you also have to enclose orders in double quotes in the from part. So here I am going to add double quotes. Now let's hit enter. It is showing a pipeline stage specification. Okay, so I've made another mistake. You have to remove this bracket from here and place another closing bracket. So all of this data is going to go inside the lookup operator. So the lookup operator will have a from field, a local field, foreign field, and an alias. Okay, now let's hit enter, and you can see that it has aggregated the data for us. Let's go ahead and see what is present here. So the first document here, where the name is John, age is 28, and you have the payment method, you have the orders having order ID 2 and 4, and then a new field is added called order details, in which it is fetching the data for the order ID 2 and order ID 4. And if you scroll down a little bit, you will see that same is the case for the second document, where the orders array contain values 1, 3 and 5, and now a new field order details have been added, which is containing the values for these order IDs. So this is how you can establish a one-to-many relationship between the collections using references. So that's all for this video. I'll see you in the next one. In the last few lectures, we have learned about relations in MongoDB in great detail. We saw some scenarios where we need to use embedded documents to create relations between two collections, and we also saw some scenarios where we need to use references in order to create relation between the two collections. So we talked about one-to-one relationship between the two collections and one-to-many relationship between two collections. Now in this lecture, let's talk about many-to-many relationship between the collections and which approach we should use in order to create many-to-many relationship between two collections. Let's first understand many-to-many relationship with an example. So let's say we have an orders collection and we have a products collection. When a customer purchases something from our application, when he makes an order, a document will be created in the orders collection, and that document will store details of that particular order. For example, the order ID, that order was made, but the products were bought in that order, all those details, and in a single order, a customer can purchase multiple products. So, for example, for this order 1 document, let's say the customer has purchased product 1 and product 3. In the same way, for the second order, the customer has purchased product 1 and product 4. For the third order, the customer has purchased only one product, and for the fourth order, the customer has again purchased two products, product 3 and product 4. So here in a single order, we can have multiple products, and one product can be ordered in different orders. So here one order can have multiple products, and one product might have been purchased from multiple orders. So in this way, we have a many-to-many relationship between orders and products collection. And when we have many-to-many relationship between two collections, it's always recommended to use references because there are several drawbacks when we use embedded documents for creating many-to-many relationship between the two collections. Let's see some of the drawbacks. So the first drawback is that the document size might exceed 16 MB. In a single order, the customer might have purchased multiple products. So in this case, when we use embedded document for creating the relationship in the same order document, we will also have multiple product documents, and that can increase the 16 MB size limit of that order document. So this is one drawback. Next, we can have duplicate or redundant data in the same orders collection. Different orders might have the same product purchased. For example, when the customer made his first order, he purchased product 1 and product 4. And when the customer made the order, in that case also product 3 and product 4 were purchased. So in this case, product 4 is common for this order and for order 1. So here we will have a duplicate entry for this product 4. Another major drawback is if any product property changes, it needs to be updated at multiple places since we have duplicated entry. Now let's quickly see how you can actually implement this many-to-many relationship in MongoDB. So in the previous video, if you remember that I created an orders collection. So let's quickly curate to see what is present inside the orders collection. So you can see that right now I have 5 different orders, and each order have product ID field containing multiple values inside it. So now I'm going to create a products collection so that we can create a many-to-many relationship between the orders and the products collection. So this is the data that I'm going to insert inside my products collection, having ID, name and color, and all of the documents have different fields inside them. Let's copy all of this. I'm going to go back to my Mongo shell and I'm going to paste all of this here. So once this is done, hit enter and you can see that 5 documents have been inserted. Now if I go ahead and run the command db.products.find to see the data, you can see that this is the data which is currently inside the products collection. But before using the lookup operator to join the two collections together, I am first going to drop my collection of orders and create a new one so that the product IDs inside the orders collection can match these IDs. So I'm going to run the command db.orders.drop. So you can see that our orders collection has been removed from here. Now I'm going to clear the screen and I'm going to copy these from here, in which the product IDs actually match the IDs of the product inside the products collection. Go back to my Mongo shell and I'm going to paste all of these here, hit enter, and 5 documents have been inserted. And these product IDs actually match the products which are present inside the collection. Now let's quickly go ahead and use the aggregate function with the lookup operator. So since I have added product IDs inside the orders table, so I'm gonna go inside the orders collection and use the aggregate function here, and then inside the aggregate function you have to define the operator lookup. And as I've already discussed in the previous video, that it takes different fields. The first one is the from value, in which you have to provide the collection name. So the collection name with which we want to join orders is products. So I'm gonna pass products here. Then you have to provide the local field. So the local field is the field which is containing the data of our other collection. So here you can see that PID is the field. So I'm going to pass PID here, and this PID actually corresponds to underscore ID of the products collection. So that is gonna be our foreign field. So I'm going to define foreign field and I am going to pass underscore ID here. Then you have to provide an alias. So I'm going to say as, and I will say product details. Okay, so once this is done, now MongoDB is going to join the orders collection with the products collection where the local field is PID. Okay, PID has a small d. Where the local field is PID and the foreign field is underscore ID. And we have used the alias for product details. Hit enter and you can see that it has fetched the data for us. If you scroll up a little bit, go to the ID 1, you can see that this is your first order having the product ID 1, 2, 3, 3, 4, 5 and 4, 5, 6, and then you have a new field by the name product details, and it is containing the product details of the 3 products which are present inside the product ID, and same goes for all other orders. So this is how you can show many-to-many relationships in MongoDB using references. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm gonna show you how you can set up a shared cluster in MongoDB Atlas. After signing in into the MongoDB Atlas, this is what you are going to have. So the first step is to create a database, and for that I'm going to click build a database button in the database deployments. Here I'm going to select the shared tier, and now it gives me an option to create a shared cluster. Here you have to select a region. I am going to select the default value. You have to select a region where you want to deploy your database. I am going with the default value. You can change the cluster tier and additional settings, and you can give a cluster name. I am going to name it my cluster and then click create cluster. You can see that it is asking us how would you like to authenticate your connection. I am going to select username and password. You can also select certificate. Here I am going to provide a username and a password. Then I am going to click create user, and this is going to create the credentials for the user which will be used to access this database. Then it asks us where would you like to connect from. I am going to click my local environment because this is what it allows on the free tier. Okay, then we have to provide the list of IP addresses that will be able to connect to this project's clusters or the project's database. So you can provide your system's IP address. I am going to simply assign 0.0.0 so that all the connections are allowed for this database, and then click finish and close. The deployment is going to take some time, and once it is created, you can either create another database in the cluster or you can connect to the cluster. What I'm going to do is I'm going to connect to this cluster. Here you have different options: connect with the Mongo shell, connect your application, connect using MongoDB Compass, and connect using VS Code. I'm going to select the connect using MongoDB Compass so that I can visualize the data and insert it. Here it asks you if you have a MongoDB Compass or not. If you do not have a Compass, it provides you the link so that you can download it, but I already have a Compass, so I'm going to select this value. And here it has provided me the connection string through which I'm going to connect to the database using the MongoDB Compass. Okay, I'm going to copy this and you can close this. So this is how you can set up a cluster in MongoDB Atlas. That's all for this video. I'll see you in the next one. Welcome back. In the previous video, you learned how you can create a cluster in MongoDB Atlas. Now I'm going to show you how you can connect your MongoDB Atlas with the MongoDB Compass. Move towards your MongoDB Compass, and here in the URI, place the connection string, and in the password value, you have to provide the password which you created while creating the user. Okay, and then simply click connect. The connection is going to take some time, and after a while it will be connected. Here you can see that 2 default databases are present in the cluster. Let's create a new one. I'm going to call it PetDB, and I'm going to create a collection called pets and create database. Okay, so after that we'll add some data into the cluster. I'm going to insert a document. You can either add data using the JSON notation, or you can change the value to this value. Here you can simply click add and add the field and the value for it. Okay, then add another field and simply click insert. And this way you can add multiple documents inside the collection. That's all for this video. I'll see you in the next one. Welcome back. In this video, we are going to explore the table view in MongoDB Compass and MongoDB Atlas. So, we are going to start by seeing whether this has been connected to our database or not. Go back to your MongoDB Atlas. Here, click on the cluster name, and once you are within the cluster, you will see different tabs. Here, click on collections, and inside the collection, you will see that the database that we created using the MongoDB Compass has been created with the collection pets. And once I click the collection, it is going to show me the data that I inserted from the MongoDB Compass. Okay, so this is a way to connect the MongoDB Atlas to the MongoDB Compass. You and insert documents from there. You can also insert a document from the Atlas itself by clicking this insert document button. Here you can provide the values like name and give it certain name. Add another field, age, give it an age. Okay, simply insert it. Data has been inserted. Now let's check whether it is inserted in the MongoDB Compass or not. I'm going to refresh it, and you can see that data has been inserted here as well. Okay, so this is a basic use of MongoDB Atlas. You can also allow the data API to access the application and grant it the read and write access. Here you have to select the cluster for which you want to enable the API. I'm going to select this cluster, and then I'm going to click enable data access from the data API. This is going to take some time, so just wait. This is how you can enable the data API. There are other options. For example, you can add different type of triggers. Right now it does not have any trigger. You can also change the database access by adding any new user or assigning roles to different users. You can also change the network access. Here I have provided the IP address so that all users can connect to this database. You can also add any custom IP address, for example, of your own device or of your own team, so that only limited number of people can access the database. And that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can import different types of files into the MongoDB Compass. The first step in using the MongoDB Compass is to make a connection. You can either make connection with your local server or with an online server. After establishing a connection, we will add a new database by clicking the plus button beside database, and I'm going to provide a database name and a collection name. In order to import the data, I am going to navigate to the collection and then click the import data button present in green in the bottom of the screen. Then I am going to select the file type and the actual file which I want to import into the database. After selecting the data file, click on import and then click done. And you will see that all the data present in the file has been successfully imported into our sample collection of the sample DB. And similarly, you can also import a CSV file into your MongoDB collection. And that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can query the data using the MongoDB Compass. Now we are going to see how we can query the documents present in the collection using the MongoDB Compass. So for querying the data, you can use this filter part of the MongoDB Compass. Here, you have to define the field on the basis of which you want to filter out the result. For example, if I want to have all the documents for all the pets where age is greater than 5, I am going to write this query here. Here first you have to define the attribute on the basis of which you want to filter out the result, and then you have to define the condition. So since I want the age to be greater than 5, so I'm going to use this greater attribute and I'm going to define 5 here. So what this is going to do is it is going to filter out the documents where age is greater than 5. Now upon clicking find, you will see that all the documents in the output have been filtered on the basis of age greater than 5. But you can see that all the records are randomly placed. There is no sequence in it. So if you want to further modify the data, so in order to sort out the data, you can use this sort field here. Here you simply have to define the field on the basis of which you want to sort. So since I want to sort on the basis of age, so I'm going to say age and set it to 1. Okay. Now when I'll click find, it is going to sort the documents on the basis of age in ascending order. Okay, so our data has been sorted now, but you can see that all the records present in the document, for example, pet ID, name, kind, gender, age, owner, everything is showing in the output. If I want to display only the pet ID, name and age of the pet, for that I can use this project attribute. Here you have to define all the attributes for which you want to display in the output. I want pet ID, so I'm going to set it to 1, separated by comma. Then I want to have name, set it to 1, and I want to have age in the output and set it to 1. Okay, now let's click find. Now you can see that our result set is restricted to only pet ID, name and age, but you can see that this auto generated object ID is being displayed for each document. If we want to remove it too, we can simply do one thing in the project. After age, add a comma and simply write _ID and set it to 0. This means that we do not want this attribute to be a part of our output. Now let's click find. You can see that ID has been removed. Now there are two other options like skip and limit. Skip is used to skip any particular number of rows from the output starting from the first row. For example, if you want to skip first 5 rows from the output, you can write 5 here and click find. So the first 5 rows will be skipped. Okay. Now if I want to limit is used to limit the output to a certain number of records. For example, if I only want to display 10 documents from the pets collection, I am going to limit it to 10, and when I click find, you will see only the top 5 documents from the collection have been displayed in the output. In this way, you can use project sort, collation, skip and limit to query your database and filter out the result in different ways. And that's all for this video. I'll see you in the next one. Welcome back. In this video, we will learn how you can connect your Python application using any IDE to MongoDB present on the MongoDB Atlas and perform different CRUD operations on it. This is going to be a solution architecture where we will connect our Python application running on PyCharm with the MongoDB present on the MongoDB Atlas using the driver called PyMongo. Let's start creating the project. For the first step, I have logged into my MongoDB Atlas and I have already created a cluster called my cluster. So first step is to create a database within the cluster, and for that I am going to click on the cluster name, and after opening on the cluster I am going to move towards the collection tab in which I will create a dummy database. To add a database, click add my own data, provide a database name, I am going to call it testdb, and provide a collection name, I am going to call it test, and simply click create. Okay, this will take some time, and after a while your database in the cluster will be created, and you can add documents in the cluster just like you can add documents using the MongoDB Compass. After clicking on insert document button, this is the kind of data I am going to insert. So what I am going to do is I am going to add one document and then simply clone it and change the values of attributes. So this _ID is the ID of the document which will be created, and I have added a field for ID, an item, price, size and quantity, and I am simply going to click insert. After a while you will see that a document has been inserted. Now I am simply going to clone this document multiple times and then add up to 10 records. And in this way, we will add multiple documents into our collection, which is test, and click insert. After a while, you will see that all the documents have been inserted into the test collections. Now, the next step is to connect this database to our application. Since you already know that we are going to work with the Python application, so I am going to use PyCharm as the IDE for editing the Python project. You can use any other IDE that you want, but I always prefer PyCharm as it has a lot of IntelliSense and a lot of built-in modules that help in fast development of Python project. Now, after opening your PyCharm, we have to create a new project. Click on New Project. And here you have to specify the project name. I am going to call it Python MongoDB. You can give any name to your project, and I'm not going to change anything else. You can change the location of the project, the location of the environment, all other things, and then simply click Create button. The creation will take some time, and after a while, your project will be created and will be ready to go. After the project is created, you will going to see something like this, and on the left hand side you will see these directories, and inside the main project directory you will see the main.py file having this code. Now I am going to simply run the file to see that our project has been created correctly or not. Upon executing, you will see that the text that we printed using the print command is shown on the console. This means that our project has been successfully created. Now I am going to remove all these comments, and I am going to remove all the other functions that I don't need. Okay, and then we'll start continuing the actual project. Now, in order to use the MongoDB with the PyCharm, we have to install its drivers, and for installing the MongoDB drivers, I am going to move towards the terminal. And from here, I will write the command pip install. And since the driver for PyCharm for MongoDB is PyMongo, so I'm going to write here PyMongo. Simply click enter, and after a while, your package will be imported. Here, I have already installed the drivers for the MongoDB in my system, so it is not installed here. But once you are installing it for the first time, after the command, your MongoDB drivers will be installed. Now we are going to import the PyMongo into our project by using import PyMongo. Okay. Now the next step is to create a connection between our MongoDB database present on the Mongo Atlas and our Python application. So here we are going to create a connection by using PyMongo object dot type, and to provide the URL to our database. For that, we will move towards our MongoDB Atlas, and inside the project, move to connect. And then here you have different options. Select connect to your application. It will give you a connection URL. Copy it and simply paste it inside the URL area. Here you have to change the password field and provide the password that you added while creating. So I'm going to give it, and this is good to go. No, this is going to return us a client, so we are going to assign the value to a client. Okay. Next, we will use this client to get the DB, and here you can see that the name of the DB was test DB. So I'm going to define it here, and this is going to return us a DB object. Okay. Then we are going to use this DB to get the collection, and the name of the collection is test, and we are going to store it. Okay. Now after writing all these things, we are going to execute the code to see whether the code is working fine or not. Now upon executing, you can see that the process is finished with exit code 0, which means that there is no exception or no error in the code. So we can continue working forward. Now we are going to move towards insertion of data using the PyCharm into the MongoDB present inside the MongoDB Atlas. Now what I'm going to do is I'll first create a function, and I'm going to call it create many or insert many, and inside it we have to add a client, and documents object. I am using documents here because I am inserting many documents. If you were to insert a single document, you have to use a single document object here. Then I'm going to cut it from here and paste it inside the function. Then here what I'm going to do is I'm going to create a documents object inside which I'm going to paste two documents. Okay, so here I have added two documents containing the following data, and after that I have called the create many method into which I am passing this client and this documents object. Now inside this method, first from this client object we will get the database name, and then from this database we are going to get the collection, and then from the collection object we are going to call the actual insert many function of the MongoDB, and inside that we are going to insert the documents object that we want to insert. Okay, after that simply click run and you will see that our process finished with exit code 0, which means that there was no error. Now let's see whether the data has been actually inserted or not. Move towards your MongoDB Atlas, go towards your cluster. Inside the cluster, go to the collections, wait for it to load, and inside your database and the collection you will see the records that you have just added are inserted successfully. Okay, so this is how you can add or you can insert multiple documents inside your MongoDB database using PyCharm. Now we will see how we can read data from MongoDB using Python. Now firstly I am going to comment these two statements, this one and this one, because we don't need to insert documents again. I am going to create another method which I am going to call read docs, and inside that function I'll have a client object and a condition on the basis of which we want to read the data. Okay, then let's first call the method here. First I'll pass the client, and for the condition we'll create a condition variable here. So the documents that I want to retrieve are the ones where the item is cappuccino. So here I am going to define it as item is, and here I will define the condition which is going to be grade which is equal to cappuccino. Let me change one thing. I'm going to cut it from here and paste it right within the condition part. Okay, now within the read docs function, first I am going to copy these two instructions to have the DB and the collection from the client, and then for getting the results we will create a variable results, and here we will use the collection object to get the find function in which we are going to enter the condition. And for iterating inside the results, we are going to use the for loop for row in results, and we are simply going to print this result value, which is going to be the row. Now I am going to run it. Okay, so here you can see that it has displayed me 3 documents having ID 2, 6 and 9 where the item is cappuccino, and it has displayed me the price, the size and the quantity as well. And this is how you can read the documents using different conditions. Now we are going to move towards a third operation, which is to update documents present in the MongoDB database. And for that, first I am going to comment out this field because I don't want to read the data, and then I am going to create another method and call it update doc. Inside that I am going to pass a client, a condition just like reading, and in addition to these 2 parameters I am also going to pass another parameter which is gonna be an operation. As you all know that for updation we need to have a condition on the basis of which we filter out the documents that need to be updated, and then we define an operation which is to be performed on the selected documents. Okay, so after defining these things I am going to copy the client and collection instructions. I am going to paste it here, and then I am going to use this collection to call the function update many, and inside this function I will insert condition and operation. and this is going to return me results. So I'm going to store it in results. After storing this in the results, we have to get the number of rows updated. So instead of iterating through the results, we will simply print results dot modified underscore count, which is going to return the number of documents that were updated as a result of execution of this particular instruction. Now we are going to call it, and for that we will move here and we will simply call update docs, into which we will pass the client. Then we have to pass the condition. I am going to update the record, for example this one, where the ID is 5 and I am going to set its price to 12. Okay, so here I am going to define the condition by saying that when ID is equal to 5, this is going to be our condition. Okay, and then we have to define the operation that when ID is equal to 5, then what it is going to do, it is going to set the price to 12. Let's execute the query and see the result. Here you can see that it has returned me 1 because I have a single document whose ID was 5 and I updated the price to 10. Now let's reload it to see the updated document. You can see now the price is changed from 10 to 12. And this is how you can update different fields of the document using the update function. Now we will move towards our final operation, which is to delete a particular document. And for that I am going to create another function. I am going to call it delete doc, and inside that I am going to pass the client a condition, but there is no need of operation because we already know that we are going to delete the document. Here once again I'll copy these commands, paste it here, and here instead of update many, I will use collections dot delete underscore many, and inside that I will pass the condition. I am going to paste this here, and instead of modified count, I am going to change it to deleted count because we want to get the number of documents that were deleted. Now for calling the method, I am just going to comment this instruction, and I am going to call it by its name, delete doc, pass the client, and then for the instruction, let's say I want to delete the document where the ID is 5. So here I'm going to define it like ID, and then I'll define it that it is equal to 5. Okay, so this function is going to delete all the documents where the ID is 5. Okay, now let's run this to see whether the document is deleted or not. It has provided me 0, but let's see whether it has deleted the document or not. Let's check it. Okay, so let's see ID 1, 2, 3, and okay, 4. Now the ID 5 object is missing, which means that it has deleted the document where ID was 5. And this is how you can use MongoDB and connect it with your Python application using PyCharm or any other IDE to use MongoDB with the Py. And this is all for this video. In this video, we will learn how you can use Spark with the MongoDB by using Databricks. Databricks is a data processing platform founded by the creators of Apache Spark, and it will be used to connect the Spark to our MongoDB and load the data from the Spark into the MongoDB, which may be present on your local system or on the MongoDB Atlas. So for the first step, I have logged into my MongoDB Atlas, and inside my cluster, I am going to click add my own data and give a suitable name to the database and the collection. And you will see that the cluster has been created, but right now there is no data present inside the collection. Now we will move to our second step, which is to configure the Databricks. Inside Databricks, we will first create a cluster by clicking Create from the navigation menu and then selecting Create New Cluster. Here, I will give a suitable name to my cluster while leaving all other fields as it is. The cluster creation will take a while, and in the meantime, we will move towards importing the data into the table. For creating a table, click on Create and then select Table from the left-hand navigation menu. Select the file whose data you want to import into the table. Once the file is uploaded, copy the path provided by Databricks because we will need it in future. Now we will create a notebook, which is the actual workspace for writing the code. Give a name to your notebook, select the language and the cluster where you want to create the notebook. Once our notebook is created, we are going to use the data frame object and call the function read the CSV file, and here we will provide the path that we copied earlier. Upon execution, it will display us all the data which was present in the CSV file that we imported into the table. But here it is treating the column names as a first row. To correct this, we will set the headers to true to consider the first row as the column name. Now you can see that the first row is considered as a column header for each column. Now we will move towards actually loading the data from the Spark into the MongoDB present in the MongoDB Atlas. First, we will create a variable that will store the URI where the MongoDB is present in the MongoDB Atlas by copying its connection string. Before moving forward, we will add certain libraries into our notebook. For that, we will move to our cluster, and in the libraries, we will select add new and then type Mongo and then select Mongo Spark. Similarly, we will add the XML library which will be needed for the data to MongoDB. Exporting. Let's go back to our notebook. Here, we will import the Spark session from the PySpark.sql library. Then we will use the Spark session to build the configuration which will include the URI for the MongoDB where it is present. Then we will define the input URI as well as the connector that will be used for loading the data between the Spark and the MongoDB. Here we will also define either to get or create the configurations. You will see that our query will be executed successfully without any errors. Finally, we will use the dataframe.write.format method in which we will define the data source, the URI where our database is present, which is in the Mongo URI variable. Then we will define our database name, which is SparkDB. We will also define the collection name, which is demo in this case, and we will define the mode as override to override any already existing data, and we will save it. Upon running, you will see that the query has been executed successfully without any errors. Now we will move towards our MongoDB Atlas to check whether the data has been loaded or not. Once you are in the MongoDB Atlas, reload the page, wait for some time, and then you will see that all the data from the file has been successfully loaded into our database SparkDB inside the collection demo. And this is how you can use Spark on Databricks to load the data into the MongoDB. And this is all for this video. Thank you.